Hello everyone and welcome to another episode of the WeAreDevelopers Live Days. My name is Bene. I'm here at the WeAreDevelopers headquarters in Vienna and I'm happy that you all made it today. So today is all about WebDev, but before we start, quick reminder for our regular viewers and as an info for our newcomers. The WeAreDevelopers World Congress is back as an in-person event this year from July 17th to 19th. Also in Berlin, like the last years. So after this event, check out worldcongress.dev. There you get further information on everything you want to know about this event, and you can also claim your early bird tickets. And now, before we start with the first speaker, during the talks, please feel free to interact in the chat to your right. Submit some questions via the Q&A function. If you got any, the speakers will gladly answer them after their talk. But as always, please be nice to each other and respect each other as we have a code of conduct. Here's a short video about it. And now let's kick off the WebDev Day with our first speaker. He is CEO and co-founder of Software Architects GmbH. Not only is he a developer and software architect with a passion for web development, Rust, .NET, and cloud computing. No, he's also a mentor at Coder Dojo Linz and also a regular speaker also at our conferences. Very welcome, Rainer.
Hey, Bina. Happy to be here again. Thank you for having me.
We are very happy to have you again, Rainer. So, before we start with the first talk, would you mind sharing a bit with us about what we are going to learn from you today?
Absolutely. My topic today will be WebAssembly. A few years ago, maybe WebAssembly would only be something for web front-end developers, but nowadays WebAssembly is relevant for everybody. You can run your WebAssembly code in the browser, but also outside the browser using Node.js or maybe in a cloud like Cloudflare or maybe on your Kubernetes cluster or something like this. And I thought it would be a good idea to spend an hour or so on the very, very fundamentals. So today we are not going to see shiny and blinking demos. We are really going down to the very basics of WebAssembly so that we have a solid understanding what WebAssembly is, how it works on the lowest levels, so that we are equipped for any maybe difficulties or troubleshooting that we have to do, or of course also optimizing our WebAssembly applications.
Awesome. Going back to the basics, yeah, that's always good. And what would be a more fitting talk to kick off the day? So then, without stealing any more of your talking time, Rainer, the stage is all yours.
Thank you very much. Yeah, I'm happy to be here. This topic is very near to my heart, as all the topics that I'm speaking about. WebAssembly is super interesting, at least in my area of work. I am a full stack developer with a strong focus on web. So what I typically do, I build applications that run partly in the cloud, partly on the client, and they communicate with each other. And WebAssembly gives me a platform where on which I can write code that is really portable. In the past, that promise could only be fulfilled with essentially one language, and that is JavaScript. JavaScript had a kind of monopoly in the browser, but nowadays WebAssembly broke the monopoly of JavaScript in the browser. JavaScript is still a loved language. I love to use JavaScript, TypeScript, and things like that, but I also like bringing other languages into the browser. And that is exactly what WebAssembly is all about. But WebAssembly is way more than just running code in the browser that comes not from the JavaScript world. WebAssembly is also super interesting when it comes to server and cloud. And today we want to go to the very basics, to the very fundamentals of WebAssembly and take a look what WebAssembly really is. So without any further ado, let's jump right into it. And the first thing that I have for you is a GitHub repository with a Docker image. I regularly do WebAssembly workshops, and I created a GitHub repository with all the material that you're going to see today. So if you want to try some of the samples that I'm going to show you, if you want to try the tools that I'm going to use throughout this presentation, if you're looking for the source codes that I'm going to show during this presentation, this is your one-stop shop. Just take a look at Stropek, that's my name, Wasm Workshop, and here you find the source code for the Docker image that you can use as your playground. It has all the tools for various languages installed and also links to additional material, source code, and so on. I don't use any slides for my talks, as you know it. If they are technical talks, I try to stay with code, and with that, we are going to jump right into it. Here you have some links for important materials about learning about Wasm fundamentals. And the first website that I would like to fire up here is let's say the homepage of WebAssembly. It's called webassembly.org. And here you can read what WebAssembly essentially is all about. Let's read it together, okay? WebAssembly is a binary instruction format for a stack-based virtual machine. WebAssembly is designed as a portable compilation target for programming languages, enable deployment on the web for client and server applications. Here are a bunch of very interesting things in this definition. First, we see that it is a binary API, a binary instruction format. So it's like assembler. We can take a programming language, which is stated here, and use WebAssembly as a compilation target, as you can read here. So we take our most loved programming languages like C or C++ or Rust or Go or C# or whatever you want, and we compile it not to assembler language for a certain platform, for a certain CPU architecture, but we compile it using a compilation target to WebAssembly. That gives us binary code. Now we can run this binary code, and it runs on a stack-based virtual machine. We will spend quite some time today discovering what that means. I have met countless developers who are pretty successful with WebAssembly using frameworks like in the .NET space, Blazor, for instance, or maybe write some Rust code that runs in Cloudflare, and they don't really know what stack-based virtual machine really means. After this talk of mine, you will definitely have a clear understanding what this means. Last but not least, we see it's a virtual machine. It's a virtual computer, if you want to put it like that. It sounds a little bit like languages like C# or Java, where you also take your C# or Java code and compile it to a virtual machine. There is a .NET virtual machine, or there is a Java virtual machine. So WebAssembly is also a virtual machine. It's not an existing physical hardware machine, But does that mean it's the same as in C# and Java, intermediate language, something like this? No, that's not the case. WebAssembly is, as the name suggests, way, way, way lower. It's really an assembler language. It's a language that has only a few data types, has only a limited number of instructions, and this is what WebAssembly is all about. So now we understand what this WebAssembly is all about. It's a compilation target. You will likely never write WebAssembly directly. You will always use a higher programming language and then use it as a compilation target. But sometimes you have to dive deep, and this is exactly what this session is all about. Okay, now we know what WebAssembly is. It's super interesting because it gives us portable code. Let's dive right into the first topic and the first sample. We will get back to my GitHub repository in a minute. Now, for the very first example, we are going to write a hello world application in pure WebAssembly. Now, for us as humans, it's pretty hard to write binary code. Of course, we could type in some hexadecimal numbers, but that is not a lot of fun. Luckily, there is a language which is the lowest language that you can use for WebAssembly, and that is WAT, WebAssembly text. So let's write our first sample for today in WebAssembly text. For that, I'm going to create, let's say, hello.what, for instance. And as you can see, I have installed certain extensions to Visual Studio Code so that it's easier to use what code. Just check my GitHub repository. You will find a list of all the extensions that I recommend for WebAssembly development inside of the GitHub repository that I mentioned before. Now let's write the simplest possible WebAssembly application. It works like this. We use brackets and simply say module. That's it. That's a WebAssembly module. We are talking about modules, and we can, in fact, convert and compile this module very easily in the command line. Let's fire up a terminal window here, and let's compile this super simple, not very useful, granted, but it is a working WebAssembly module. Let's compile it. There are so-called WebAssembly binary tools, WebAssembly binary toolkit, the WABIT, and inside of the WebAssembly binary toolkit, there is a tool which can turn WebAssembly text into WebAssembly. We do that by using WAT to Wasm. That is the tool that we use. And we say hello.what, give it the thing here. And if we take a look here, we have a Wasm file. Now, this Wasm file is binary, as you can see, but we can use, for instance, a hex editor to take a look, and you see it's only 8 bytes long. It has some header at the beginning. We have the 0 here, then we have ASM, these 3 ASCII characters, and then essentially we have nothing because our module is completely empty. I just wanted to demonstrate how this generally works and how the tools work. So we have successfully built our very first WebAssembly module in WebAssembly text, the lowest level that we can get. Now, let's add a little bit of functionality here. So let's go here and say, okay, use a bracket again. Let's do it like that. And then let's define a function. Yeah, WebAssembly text supports functions. In contrast to virtual machines like from C# and Java and so on, WebAssembly is by far not object-oriented. Don't get a wrong impression here. That's not the same as a Java virtual machine or something like this. Yes, you have functions. Yes, you have basic numeric data types, but that's it. There is no higher level programming language here. WebAssembly doesn't support or doesn't know about classes or inheritance or interfaces or virtual methods, not even memory allocation. These things are not present in WebAssembly, as we will see. But we can define functions, and in this case, we are defining a function which is called $ping in this case, and this function should get a parameter, this one, and it is a parameter called in of type i32, and that's our input parameter. The caller of our WebAssembly method has to push an i32 value onto the stack, and we can then process this value. Now, the next thing that we do is we will define that we also return something. In this case, we are returning a result, which is also of type i32. And now the question is, how can we return something? Well, the caller of this method will push our input parameter on the stack. We have already learned that WebAssembly is stack-based. So handing over parameter means pushing the parameter on the stack. So if we want to return something, we have to push something to the stack also. But we want to, in this case, ping, just take the input parameter and return it. So what we are going to do, we are going to say local get $in, and that's it. The local get method here is just popping the input parameter from the stack and pushing this input parameter on the stack again in order to return the result. And this is exactly what we need. Nothing more, nothing less. So this method, we learn from it. WebAssembly understands functions. WebAssembly has data types, basic data types, only some basic numeric data types, nothing fancy, no structured data types, no strings, nothing like this, just the usual floating point and integer data types, and everything works across the stack. So in this case, we pop and push things on the stack, and we will learn more about this in the upcoming minutes. Last but not least, we need to export our function, export. What is the name of the export? Let's call it ping. And exactly that, GitHub Copilot is already suggesting a little bit. Yeah, GitHub Copilot can speak WebAssembly text. So if you want to learn WebAssembly text, GitHub Copilot is a good way, or ChatGPT in general, is a good way of going about it. So this is the next level of our program. This is assembler as it is written with WebAssembly. And let's compile this thing again. And let's take a look at the binary file again. And you see we have a little bit more. Now we see that each WebAssembly text statement is converted to the binary representation of the corresponding statement. And because we have this export name here directly in our what text, this also shows up in the hexadecimal view of our Wasm statement here. Now you might ask yourself, what is this local get all about and where do I get information? Well, the best source for information about that is, if you ask me, the MDN, the Mozilla Developer Network, probably known to every web developer here in the course. And here you see what this what this local get is all about. It reads the value of a local variable, in our case, the input parameter which comes from the stack, and pushes it onto the stack. This is exactly what local get does. And if you take a look here on the left-hand side, you have an introduction to WebAssembly concepts and so on and so on. And if I scroll down, here, we have the, where is it? Essentially, you can look up every single instruction. Let's show it here. If I go up here, you will see some important variable instructions. If I go up here, and we could, for instance, say, what are numeric instructions? Do you maybe want to add something? Then you can take a look at it, and you see there is a statement which is called add, which we'll see in a second. And this add statement is described here, and you can immediately try it. So use the MDN to learn more about the different statements that are available in WebAssembly, and you can also dive deeper into the concepts of WebAssembly using the MDN. Now we have this hello world ping function. Of course, we would like to call this function. No problem. Let's call it in JavaScript because it is WebAssembly is already built into JavaScript. As you know, we can run WebAssembly in the browser or outside the browser. So in this case, let's say run.js, where let's write a very simple JavaScript application. The first thing is we need to load this thing from the disk. So let's do a require of our fs module and then build an async function, something like this, so that we can really run something and use the await keyword here. Well, the first thing that we are going to do is we are going to say, let's read the Wasm file, okay? fs.read file sync. And, well, this is wrong, what GitHub Copilot suggested here. It's called hello.wasm. Read file sync simply reads the bytes from the disk into memory in Node.js in this case. Then we are going to instantiate a WebAssembly module, const wasm module, and there we can say await WebAssembly and instantiate. We can do it directly because it's WebAssembly. Yeah, this is how you do it. Now we have this module. You know what? For now, GitHub Copilot Spoilers more than it helps, so I disabled GitHub Copilot for the moment. Now we have our WebAssembly module loaded in JavaScript, but this does not run in the browser. We are outside the browser, and you will see later on in a few minutes how we can also host WebAssembly in programming languages like Rust or maybe C# or something like this. I will show you Rust as an example, but here we are just using JavaScript because it's built in. So let's get the function, and in this case, we simply say, give me my Wasm module and take the instance and give me the exports. And in this case, we have, let me show you that here, one export, and this export is called ping, so therefore I can simply grab this export in JavaScript. And this is what's meant with programming language independent. WebAssembly text and WebAssembly is completely agnostic of the underlying programming language. If you have a programming language like What or C or C++ or Rust, and you can generate WebAssembly code, this WebAssembly code can be called from other languages. You're no longer bound to a single language, and that's a great thing. So now we can call this method, no problem, const result equals to ping. What do we pass in? Of course, 42. What else? And last but not least, let's do a console log statement and print the result on the screen. I think that is okay. Let's try this one. Let's say node run.js, run it, and the result is 42. So as you saw, we now wrote a low-level WebAssembly application using WebAssembly text. You learned a little bit about local get, about functions, how you can export them, and you saw how in JavaScript we can simply load up this WebAssembly file byte by byte. We instantiate a WebAssembly module, we grab the exports, we call the method. Here we are bridging the gap between what and JavaScript, and we get a meaningful result, and we are super happy. That is our first Hello World application, and that should give you an idea what behind the scenes on the lowest level really happens. Now let's make it a little bit more interesting and add a little bit more functionality so I can go into more details what this stack-based virtual machine really means. What I did a few months ago, I took one example that I get from a very famous programming puzzle that many of you are probably familiar with, Advent of Code, and I took one of the examples, day one in 2022, and I implemented it in WebAssembly text, and this is exactly what I would like to show you. Let me quickly describe what this method, what this puzzle is all about. It's a very simple puzzle, but that's good because we want to write it in assembler, right? What we essentially get is we get a long text here. And if you read the description of this puzzle, it says that you have to parse out the different values that you find in this text. And then you have to add up groups here. So the first one would be 1,000 plus 2,000 plus 3,000 is 6,000. That would be the first one. And then you do that with all the different groups. And the goal is to find the group with the highest value. So in this case here, we have 24,000. And I think that is the highest value. So this would be the result, 24,000. This is already an interesting challenge because the input that we get into our program is a string. And WebAssembly doesn't support the string. So we have to think about memory management. Next, we have to do some simple parsing. We have to convert ASCII into binary numbers, into integer numbers. Then we have to do some aggregations, some grouping like that. We have to do some comparison. So this example seems to be trivial if you use a programming language like C# or Java or Rust, but it is not trivial if you use WebAssembly text. And now I would like to walk you through a sample implementation of exactly that example. Let me open up this one, and we are not going to type this by hand because it's too long. I only have 45 minutes, so essentially I would like to walk you through this code, okay? First, we see our ping method that you see here. It's just for demonstration purposes, I included it here. But next, I would like to jump into this function here. It says parse num, as you see it here. Now, this parse num feature does what the name suggests. It takes a fraction of the string, to be more specific, starting at the index $ix, and parses the number with a maximum length of the string of $len. So what we essentially get, if I take this one, is at the beginning, we get this entire string as our input, and the first call will be index 0, and the length will be the total length. And we have to stop parsing when we either find a \n character or when we are at the end of the string reaching the $len, the total length of the string. So that is the task of this method. And let's take a look how this is done. Some of the things should now already be familiar with you. You know what a function is, you know what a module is, you know what this param is. We get that through the stack. And now let's take a look at the implementation. What you see here is, yes, again, we can have a result, but it's an interesting thing that WebAssembly functions can return multiple values. That's absolutely possible. So in this case, we are returning 2 different values from our method. The only thing that we need to do in order to return multiple values is we have to push, at the end of the method, we have to push multiple values onto the stack so that the caller can pop both results from the stack. This is what this result I32 2 times means. Then we can define local variables. Essentially, these local variables live on the stack. So here we define a local helper variable called $num. And yeah, I think that's pretty obvious what we do here. Then we start a loop, which we call $loop. We will see how this loop plays out later. There are no complex control flow statements like a for loop where we can immediately do something like a C for loop or something like this. No, this is just essentially a label where we can easily jump back to later on. And now it becomes really, really interesting because now here in this case, we need to perform some business logic, which is a little bit more complicated. Essentially, what we do, we check whether the element at the current index is a \n or whether this is the end of the input, because then we have to stop processing. So that's essentially saying if I have reached a \n or I have reached the end of the input, then stop. Or in our case, it's the other way around. We say if we do not have a \n and we do not have reached the end of the input, then we can process the character. That's essentially what I have written here. Now let's take a look at this statement here. I will zoom in so you can see it very clearly. You have to follow the braces here. We have to find the most inner braces. And what we see here is, as you can see here, we have braces here that say local.get $ix. Can you remember what local.get does? Local.get takes the value of a local variable, in our case, the $ix variable, and pushes it on the stack. So it loads the value of $ix onto the stack. Why do we need it on the stack? Because, and now I need a different color here, because the next statement, which is wrapped around this statement here, is called load 8u. And that's essentially taking 8 bits from memory. WebAssembly has a dedicated memory. We have to declare the memory. I will show you that later on. Essentially what it does, it reads a byte from memory. In memory, we have the string. The question is, which byte should it read? The answer is the byte of the value which was pushed on the stack before. So if we want to index our memory, we have to push the index on the stack so that load 8u will pop this index from the stack and again pushes the byte that it finds at the corresponding memory location onto the stack again. So it's a constant pushing and popping on the stack. We push the value of x on the stack, this is popped by load 8u. This will push a byte on the stack again. Now, the next thing that we see here, essentially it's not a byte, it's an I32. It only loads a byte, but it pushes 4 bytes in this case because it's I32. The next thing that we see is here we are pushing the constant 10 on the stack. So now we have 2 values on the stack. We have the value 10 on the stack, and we have the character at the index $ix on the stack. And that brings us to the next statement, which is this one, which is a not equal. So we are comparing whether two values are not equal, and guess where these values are taken from? They are taken from the stack. So this pops the first value from the stack, that is the current character. It pops the next value from the stack, that is the constant 10, and it pushes either 0 or 1 on the stack, depending on whether it's not equal or not. The same happens in the next line, where we compare the $ix with the lang. We push both on the stack. The not equal pops both from the stack, pushes 1 or 0 onto the stack, and then that brings us to our last statement here, the AND statement. This again pops two operators from the stack. Both must be 1 in order to enter the if statement, otherwise it's not entering the next statement. So as you can see, in this case, the AND pops two values from the stack, and to be more specific, what AND does, it pushes, again, a value on the stack, either 1 or 0, so the next statement, the if statement, doesn't have a condition. Where does the condition from? From the stack. It pops the value from the stack, and the value was pushed there from the AND operator, as you can see it here. So this is meant by a stack-driven virtual machine. Everything is going over the stack. Do you want to call something? Do you want to pass a parameter to a built-in operator or something like this? You have to push everything on the stack. And it's very clearly defined. Every single operation in WebAssembly has a clearly defined number of elements that it pops from the stack, and a very clearly defined number of elements that it pushes on the stack. And when you run what to Wasm, then what to Wasm will check the consistency of the stack. So if you make a mistake, for instance, and you call and what to Wasm will recognize that there is only one element on the stack, but and needs 2, it will not compile your code. So that's the only check that's going on. So the stack consistency is given. You cannot break stack consistency here. That would be a mistake in the implementation of the compiler. And that is a very important thing here when we talk about WebAssembly and its security. Well, in reality, the code looks a little bit different. Let me show you what I mean by, again, converting this code into WebAssembly. So let's do what to Wasm aoc1.what. Let's compile this thing. Where am I? Oh, I'm in the wrong folder. I'm super sorry. I have to go one up and call it again. Okay, now I compile it to aoc1 Wasm, and then I'm going to call Wasm to what? It's the other way around, aoc 1.wasm, and put that maybe on the screen like this. And what you see here, if I go through this, you will see this looks like the method that we just looked at. This is what WebAssembly at the end of the day looks like. It's not like we have seen it before, that it's nicely in braces or things like that, but essentially the whole statements are reordered. So WebAssembly executes these statements by pushing and popping values in a sequential row. So this one would push something on the stack. This one would pop one thing from the stack and push one on the stack, exactly what we discussed before. This pushes one from the stack. This pops two values from the stack and pushes one from the stack. But we, as humans, it is pretty complicated for us to read code like this in a sequential order, having to remember what is pushed and popped from and to the stack. If you write it like that, it's way, way, way more easy to read, because with the braces, it's kind of how we could express it in natural language. Take this parameter, take this parameter and use this as an input for this operation. Take the result of this operation, take the value 10, and take both as the input to the not equal. Take both not equal operations and use this as the input for the AND operation. So for us as users, it's much easier to read code like that, and there are tools with which you can format Wasm into this kind of what code, or vice versa, which I just showed you. Now, the rest of the code is essentially exactly the same. If we would have a lot more time for this Wasm workshop, we would spend more time taking a look at implementing a formula like that. But at the end of the day, it's always the same. push something on the stack, push something on the stack, multiplication pops two values from the stack, multiplies it, and pushes the result onto the stack. Same is true for subtraction. Same is true for addition. Then we set everything into a local variable, which is essentially pushing a value on the stack, and so on and so on. The return statement is not a return statement, but if we want to return values at the end, we must push two values on the stack. And this is exactly what we do here. We push two values on the stack. That is our result. And if I scroll up a little bit, that must correspond to the number of results that we see here. If I mess up, for instance here, if I get rid of that one, and if I, let me stop that one and do this again, if I run this, then you will see we have a type mismatch. The system expected two i32s, but it only got one i32 because we did not push enough values onto the stack. So therefore, WebAssembly cannot be generated. I hope you understand what this is all about, and now you have an idea what stack-based virtual machine really means. Now let's switch gears and talk a little bit about the next thing that we absolutely have to understand before we run this example and see that it really works, and that is memory. You have to understand that WebAssembly at its core can only work with the stack and has a very clearly defined instruction set that is only capable of, I don't know, manipulating some bits and bytes in memory. WebAssembly at its core cannot somehow access your precious memory of other processes running on this machine. That's simply not possible because there are no WebAssembly operations for that. Many people ask me what virtual machine means. Does this mean it works like a virtual machine in a hypervisor? Or does this use Linux namespaces like containers, for instance? No, that is not what the virtual machine in WebAssembly is all about. The virtual machine in WebAssembly simply states that you do not have operations that can perform something bad. You don't have an operation where you can access random memory on your computer. It's simply not present. And therefore, if you compile anything, even unsecure C code into WebAssembly, and you run it on your precious development machine, this WebAssembly code cannot perform anything bad with your machine because there are simply no operations which could be executed. It's not defined in the WebAssembly standard to perform something bad. However, sometimes we need to have more than a bunch of integer and floating point values. For instance, structured data types, strings, and so on. And for that, enter WebAssembly memory. WebAssembly memory is linear memory. So essentially what you say here, I allocate a memory page. That means, I don't know, 64K or something like this. You can also allocate more memory pages if you need to. I will not go into the details because typically you don't see this at all. I just want to understand, I want you to understand what this is all about. Essentially, here we are allocating a bunch of bytes in memory. Okay? These bytes, let's draw it like this, are linear memory. So WebAssembly has no idea how alloc or free could work. It's like in the old days. I'm pretty old. I am in the software development business for more than 30 years. And in my early days, what memory was for me is simply a continuous range of addresses where I can read and write bits and bytes however I like. And this is what WebAssembly memory is all about. No structured memory, no allocation and deallocation, no free memory list, no garbage collector. It's simply a list of bytes. And if you want to read a byte from this memory, you can do so, and we see that here, by using the according WebAssembly statement. In this case, load a byte at this address. This index is essentially an address, and this is what this memory is all about. And the important part of this memory is that this memory is dedicated to this WebAssembly module. WebAssembly cannot address your entire RAM of your machine from the first byte to the last byte. It can only access the dedicated WebAssembly memory. And the only two parties that can access this memory are the host, the one who is hosting your WebAssembly module, could be JavaScript, could be Rust, could be .NET, whatever, and the WebAssembly itself. But WebAssembly cannot break out of this dedicated memory part. There is simply no statement for that. And this is why WebAssembly is a sandbox and why WebAssembly is secure. It has nothing to do with Linux namespaces or something like this. It is secure because it has a memory which is reserved for the WebAssembly module and the host, and that's it. No other memory can be manipulated. Now, sometimes WebAssembly wants to do things it cannot do by manipulating memory. Think about calling a web service. So you need to communicate with the network. Can you communicate with the network? No, you can't, because the only thing what you can do in WebAssembly is manipulate memory in the stack. And that's it. So you cannot talk to your network card. Or maybe you want to access the disk in order to read a file from your operating system. It's simply not possible because WebAssembly cannot communicate with the operating system. For that, we need so-called imports. Imports are functions that the host can provide. The host provides these functions, and these functions allow WebAssembly to call back to the host and tell the host, please do something on my behalf. In this case, I am registering here a callback method that WebAssembly will call whenever it found a number. So when it found this 1000, we will call back to the host and say, hey, host, by the way, we have found a number. And then we call the host and say, hey, host, we have found another number, and so on. But use your imagination. This could be calling the host and telling the host, please use the network to communicate with this and that web service, or please read that file from disk for me. Okay, this is what import is all about. So when WebAssembly wants to, let's say, break out of the sandbox and access memory which is not WebAssembly memory, or access I/O and things like that, it needs the help of the host. And the host is JavaScript, your browser, Rust, Go.NET, wherever you want to run these WebAssembly modules. This should now help you to understand why these WebAssembly modules are so widely used. For instance, in the cloud environment, imagine that you are a cloud hosting provider and you accept code from untrusted sources to run in your precious data center. How can you make sure that this code isn't trying to destroy the host machine? Well, you could use the virtual machine for that. That's pretty heavyweight. You can use a container for that. That's, again, pretty heavyweight. Or you simply accept a WebAssembly module, because by running the WebAssembly module, you can absolutely be sure that this module has no way of negatively influencing the host. It can only access external resources by methods that you, as the host, have to provide. Okay, enough theory. Let's run this thing. I have created some just files. Let me show that this really works. Just build that will call what to Wasm, and then we can say just run in Rust, for instance. And as you can see, it really works. We find the result with 24,000 and we see the callback value. Let's quickly take a look at the host, how such a host looks like. I will not go into details because we are low on time. Here you see how this hosting would look like in Rust. Essentially, you define the input parameter, which is a bunch of bytes, as you can see here. And then you write code, which is very similar to the code that I showed you before. Essentially, we are loading the WebAssembly binary from disk. Then we are defining, as you can see here, the callback method, which we will pass into WebAssembly. So the callback method can be a method in the host. It's very simple. In this case, we simply define a Rust method, which takes an integer and prints this integer on the screen. Then we grab the memory and copy the string into the memory location into the WebAssembly module, so we can access the WebAssembly memory from the host and WebAssembly itself. And last but not least, we simply call the method that we want to call. In this case, we are calling the getMax function. It gets the maximum value, and we print everything on the screen. So this is what I just ran. This is just Rust code. Executing this, everything is good. Do you want to see how this looks like in TypeScript, for instance? Very similar. In TypeScript, you would have, again, a string The problem in TypeScript is that a string is UTF-8, so you need to convert this string into characters, into bytes, essentially. But this is pretty simple. Luckily, JavaScript is capable of doing that. We are simply loading the WebAssembly file. We are defining the callback. In this case, the callback is in JavaScript, not in Rust. I told you, WebAssembly is bridging the gap between the programming language here. We are getting WebAssembly memory. We are using the text encoder from JavaScript to turn our string into bytes, write that into the address 0, because why not? It's linear memory, so use address 0 into this memory, and then we simply call the method from JavaScript. And as you can see, although we have implemented our module in WebAssembly, in pure WebAssembly, in WebAssembly text, it's very easy to call this in JavaScript, to host this in Rust, or even I have here an application in C#. Here you see this C# is really similar. In this case, the callback is written in C#. Then we take the string, we convert this string into bytes by using getSpan. In this case, if you are familiar with C#, you recognize the unsigned 8 here and the getSpan. And then we simply run the method, and that's again the getMax function. So it's really, really simple to host this stuff in your own application, but you have to convert, you have to do the entire memory management on your own. That's a very important understanding. If you take the C# code and convert it and compile it to WebAssembly, you have to bring your own garbage collector with you. If you take C and you compile it to WebAssembly, you have to bring your own memory management with you, because WebAssembly doesn't know about malloc and free. If you are Rust, you have to bring your own allocator and deallocator with you, because WebAssembly simply doesn't know about it. It's just linear memory. So now you understand what compile target means. It's not just converting the bits and bytes from your source code into WebAssembly binary code. It's also the entire memory management that you have to do. Last step, and then I am done. Let me go back to my playground here and delete everything. That's always a good idea, to delete everything. And then we are going to take a quick glance at one last concept here. I will, in this case, now create a Rust application. Here we are. Let's go into this hello here. And then I'm going to cargo build. That's simply building our Rust application with a target, and that's Wasm32 WASI. Why WASI? I will talk about that in a second. And then we will turn, that gives us, by the way, here in the target folder, debug and where is it? Debug and here wasn't 32 and there debug, and oh, I took the wrong one. Here it's the right one. This gives us this Wasm file here. So let's copy this path, relative path, Wasm to what exactly, and give it that one. We are here in this folder, and write everything to hello what. Hope this works. Here is our what file. And now, why I did this example now with you is because we have a print line statement in this Rust code. Now, I told you that WebAssembly cannot access your I/O. It's simply not possible. But print line writes on standard out, right? So this application should, strictly speaking, not be possible in WebAssembly. And essentially, it isn't. If you take pure WebAssembly, this method, this function here, or this code is not possible, because WebAssembly cannot print on the screen. It needs to access an operating system file, a file handle for standard out, in order to print something on the screen. Enter WASI. WASI, WebAssembly Systems Interface, is an API, a standardized API with functionality like file access and network access and things like that, where leading industry companies came together and defined a set of APIs that a host must be able to provide in order to allow WebAssembly limited, but at the end of the day, it allows access to the outer system, to the host, to network, to disk, to console, and things like that. And if we take a look at the what implementation here, you will see here the word WASI preview 1. The current version is preview 2, which is currently under development, so WASI isn't stable yet. And here you see a method which is called fdWrite. And this fdWrite allows us, if you look it up in the documentation, to write strings onto a file handle, and in this case, a defined file handle would be for standard out. So this is how this Rust application makes the magic to print something on the screen. I can run this thing. I can say Wasm time. This is a runtime, and let's do it like that. Wasm time. And let's run this WebAssembly using a runtime, and it prints something on the screen. And how is this done? Well, the host, which is called Wasm time, implements WASI, provides this method, and through this imported method, WebAssembly is now capable of writing something into a file which is standard out, and this is exactly what's happening. So WASI is a super important concept. Let me close by opening up the corresponding website. Oops, sorry, this is not what I wanted. Where is my, yeah, here we are. Here we are. It's on the, I simply took the wrong. Here it is. So this one, it's wasi.dev, sorry. Here you see this is the WebAssembly systems interface. And of course, from here, you can find the GitHub repository, which you will find here. And in this GitHub repository, you find links to additional resources where you can learn a lot about that. And I also added the GitHub repositories links and so on to this README file. There is a second iteration of WASI, which is called WASIX. WASIX is a superset of WASI, and it adds important additional functionalities. It's kind of a shame that WASI and WASIX are driven by different companies. So WASI is a kind of standard, while WASIX is not a kind of standard. The companies, especially you can find it down here, Wasm, which is a WebAssembly runtime, they think that WASI is moving too slow, and so they initiated WASIX, which is a superset, so it's compatible to WASI, but it offers more functionality, as they call it, for enabling real-world applications. For instance, it already has full networking support. It already has multi-threading support. It has an asynchronous runtime. It offers more functionality in terms of processes, forking, and so on, in order to allow more applications being written with WebAssembly for the server and the client. So WebAssembly on its own cannot do very useful things. It can only manipulate bits and bytes on the screen, in memory. But at the end of the day, with WASI and or WASIX, WebAssembly gets new capabilities by calling to its corresponding host, and I showed you how this works. So my goal today was to give you an idea what WebAssembly is on the lowest level. We have learned what virtual machine means. We have learned what stack-based operations means. You have seen how to compile what to Wasm. You have learned a little bit about WASI. And with that, I hope you enjoyed the session. I hope you took away some interesting knowledge. And maybe Bene is already here and we can do a quick Q&A for the remaining, 9 minutes if my clock works correctly.
Yes, I was here the entire time, of course. And yeah, 9 minutes left. So I would say without further ado, let's jump into a quick Q&A as we got some questions from our viewers.
Shoot.
So first one, what are some good use cases for using Wasm over JavaScript?
Very good question. Well, first, if you already have existing source code and you would like to run it in the browser or in a sandboxed environment on the server, then you should use Wasm. Imagine that maybe you have done your backend development using, let's say, Rust, and you need some business logic that you already implemented in Rust, and you need to run it in a client application in the browser, for instance. How would you get it to the browser? Well, compile your Rust code to WebAssembly and run WebAssembly inside the browser. That's the first thing. Second thing, JavaScript is good, JavaScript is fast, but JavaScript is not very good when it comes to certain applications. When it's very compute heavy, when you have to do a lot of work with integer data types, there are some limitations to multi-threading and things like that. So JavaScript for certain applications, especially games and other, and maybe CAD software and so on, JavaScript is not the fastest language on earth for doing that. There are other languages like C and Rust which can produce faster code. So take your C or Rust implementation, compile it to WebAssembly, and you will end up with a faster version of your application. So these are just two examples why Wasm is sometimes really important. But let me point one thing out at the end, Bene. Many people have the misunderstanding that WebAssembly is always faster than JavaScript because one is called assembly, must be fast, right? And JavaScript must be slow, right? That's not the case. In many situations, JavaScript is in fact equally fast or even faster than WebAssembly because, as you've seen before, WebAssembly is a very dumb platform. It doesn't know how to perform useful things on its own. You always have to bring a lot of stuff with you, and a short application in a higher level language like C++ or Rust will end up with a large WebAssembly application, and therefore sometimes WebAssembly is slower than JavaScript. So don't take your JavaScript, throw it out of the window, convert everything to Rust, compile it to WebAssembly, and then hope that everything is faster. Test first. Okay, that's a very important one.
As usual, it depends.
It depends, exactly. The perfect consulting answer. Consultants always say, it depends.
This is what I learned from moderating live days. It's always, it depends.
It depends. Yeah.
All right. Thank you for your answer. And we jump to the next question, which is, can you use WebAssembly in an AWS Lambda functions?
Very good question, and I don't have the answer. I am very much familiar with the Azure platform. I'm very much familiar with Cloudflare and a bunch of other smaller clouds, but I am absolutely not familiar with AWS. That does not say anything about the quality of AWS. It just says something about me being lazy or my day only having 24 hours. I have to focus somewhere, and I am unfortunately not familiar with AWS Lambda and its limitations or capabilities. Sorry.
That's no problem at all. We actually have a speaker later from AWS, so
perfect.
Maybe
he
let's
will
keep
probably
this
be able
just in the backlog. Yeah.
He will probably be able to answer it.
All right. Thank you, Rainer. Next question for you. Is there some kind of type definition to get type support for the Wasm code?
Oh, very good question again. Unfortunately, I only had 45 minutes, so I couldn't, I had to leave out so many things. Yes, there is a project which is called WIT, WIT, WebAssembly Interface Type, also known as the WebAssembly Component Model. The whole idea of WIT and the component model is to define a type system which sits on top of WebAssembly and allows you to declare structured higher level data type and add a little bit of memory management. Because in real life, if you have a Go application, for instance, talking to some Rust code which was compiled to WebAssembly, it's pretty hard to bind these two things together because natively they can only exchange integers and floating points. If you want to exchange something more useful like a structured data type or maybe some strings and things like that, you have to make sure that both programming languages understand what a string is or what a structured data type is. And that is exactly what the WIT project and the WebAssembly component model is all about. Bene, I think we have to do another session at another time because there are so many additional projects. But very good question. I hope I could answer it.
Rainer, there's always an open slot for you at our live days.
Thank you.
So, but I think if we go on with this pace, then we have like the next 10 topics for you already at hand. So I have
Perfect.
no worries there that we that we run out of things we can talk about. But yeah, for now, I would say let's jump to the next question.
Yep.
Rainer, do you have some tips for implementing complex data structures and algorithms in WebAssembly when transitioning from languages like Python or Java?
I'm not 100% sure about where this language is going to. One thing could mean is what could you, for instance, implement in WebAssembly in order to learn about it when you transition from Python or Java? I think everything where you do some simple rendering stuff, maybe you can build a simple game or something like this where you do the rendering work, the calculation of the bits of the pixels, where you do it, for instance, in Rust, and then you take this application and host it in a website where you use a canvas and transfer the bytes that were generated in WebAssembly onto pixels on the screen. That is a possible answer if you mean with transitioning learning WebAssembly coming from Python or Java. If you mean how can you use WebAssembly when you write Python or Java and you want to host WebAssembly, well, that is unfortunately not that simple, because the answer is exactly what I said before, the WebAssembly component model, and the WebAssembly component model is under heavy development. So the story of mixing languages like Python or Java with WebAssembly and Rust and so on is not the best. It's okay. The story is very good when you want to mix WebAssembly native languages like Rust with JavaScript. So the interoperability through WebAssembly between Rust and JavaScript is perfect. It's really, really good. But if you want to mix other languages, take a look at the WebAssembly component model. But be prepared, that's not the simplest thing to do.
A warning here at the end. Thank you, Thank you, Rainer. We have time for one more question.
Okay.
Let's take this one. How can I efficiently debug and profile performance issues in WebAssembly?
That's really a tooling question. And the correct answer is, Bene, it depends. It depends on the programming language. It depends on the programming language, really. For instance, I will take an example where it works very, very well. For instance, if you take C# and .NET, C# and .NET have a heavy investment in WebAssembly. You know, maybe the Blazor project, maybe some of the web developers are familiar with Blazor, which allows you to write your business logic in C# and not in JavaScript. And there, if you use the Microsoft tools, Visual Studio Code, .NET, and Visual Studio, and you compile your C# code into WebAssembly and you would like to debug everything, you simply set a breakpoint, press F5, start debugging, and it will automatically hit the breakpoint. You can debug it, everything is fine. But this is really a feature of the tooling of the platform.NET. It's not something that is built into WebAssembly. If you would like to really debug pure WebAssembly, Chrome can do that. So the Chrome debugger can debug WebAssembly, but you will end up with what? With WebAssembly text code. That's another reason why it makes sense to know basics of what. So you can do some debugging, you can do some performance issue analysis and so on. But again, a word of warning, it will be on a very low level, as you've seen today. If you want to have a higher level debugger, for instance, then you have to take a look at your corresponding language, Rust, Go, C#, .NET, whatever, and what they support.
All right. Then, Rainer, thank you so much for answering all these questions. Also, thanks for the talk, of course. What a great talk to kick off our day, really.
Thank you.
So, and yeah, it was nice having you again, and I think we will see each other in the future.
Perfect. Have a nice day.
Have a nice day, Rainer. Bye.
Bye.
All right, and we move on to the next speaker of the day. He's solution architect at Smapiat. He was already awarded for his with several prizes for his work. Actually, is also a Microsoft MVP, and he also teaches others by writing blogs and articles or speaking at conferences such as ours today. Very welcome, Florian.
Hello, everyone.
Hello, Florian. Thanks so much for joining us today. So,
thank you.
Florian, before we start with your talk, would you mind sharing with the audience and me a bit what your topic is all about?
Sure. Yeah, so I will be talking about micro frontends. As you might have already seen, there will be 2 talks about micro frontends, and I will be the first one to kick off this topic. I will give you a rather, let's say, shallow introduction. We will look at it from, let's say, the practical perspective. I will also highlight some issues you might run into when you embrace this pattern, and what you could do using one of the other fancy patterns that is currently out there and quite hot, which is called the islands architecture. So we will then combine both to actually see what we could get out of this and how that could help us to solve our problems that we might face using microfrontends.
All right, Florian, that sounds very interesting. And I would say, without further ado, the stage is all yours.
Thanks. So before diving into the topic, I also want to mention a few more words about me and the company I'm working for. As already mentioned, my name is Florian Rappel. I'm a solution architect. So what we are mostly doing at SmartPiot is we are helping our customers creating platforms, doing architecture reviews, coming up with concepts and all that. So everything I will be talking about is not something out of thin air, but actually it was all derived from the work we are doing together with our clients and customers. If you have any problem, always connect with me on LinkedIn, and together I think we can work something out. The experiences I have with microfrontends I've also written in a book called The Art of Microfrontends. I'm currently writing on a second edition of this book, which will be released hopefully in May or June. So news to happen soon when the final shipping date is, but be sure it will be this year. I'm already, let's say, in the closing phases. And this, of course, already opens the door to enter the topic of microfrontends. And what I want to do is not throw a lot of slides at you and then, of course, look at it from the theoretical side. From the theoretical side, I only want to throw at you a couple of slides. And most importantly, I want to highlight that microfrontends is really an organizational pattern. So what the whole pattern likes to do is it wants to enable you to have a better distribution of work. And this is all based on the observation that 3 8-person teams are in general more effective than a single 24-person team. So it all boils down to having this pizza team approach that was, let's say, really made popular by Amazon. This, of course, is based on the assumption that there is not a lot of alignment needed between these teams. So it's all about having independent teams that can now autonomously ship software. And then it all comes together at a certain point, certain, let's say, runtime, a certain server, maybe in the browser, and forms this application that the end user then uses, right? And this being said, the 2 pizza rule, so how many pizzas do you need to feed a single developer team? I'm always joking here that, so for me alone, a pizza might not be sufficient. So therefore, of course, the number of pizzas may vary by the hunger or appetite that your team has. But nevertheless, you should make your teams rather smallish, but of course still sufficiently large that they can cover the topic that they should, of course, deal with as a whole. Now, this being said, you at the end of the day need to implement it, right? So then there need to be some technical architecture behind it. And as it turns out, there are multiple ways how you can solve it. In this slide, I just want to highlight some of these approaches. There are more, and of course, there are variations of these, but rest assured, you may have already used microfrontends without even realizing. Because this first pattern that I show here, which is called the web approach, is essentially just using, for instance, an iframe where there is content now served from somewhere that you don't necessarily control. For instance, it could be ads, right? So could be some company that, well, of course, has an ad service, and via your iframe, the respective ad is in, of course, a very isolated way shown then on your website. Today, of course, this is used also in all kinds of other services. Let's take, for instance, a lot of these chatbots that are out there. Quite often, if you use a third-party service, you also bring in an iframe directly or indirectly via, for instance, a script element. And then it's the same approach again as shown here, right? So you have different servers, your server where your web application runs, and a server where, I don't know, this third-party service is now hosting their API and, of course, serving maybe their frontend from. And all you do is you embed this iframe and bring the additional UI fragment into your website. Now, of course, if you go beyond just using some micro frontend knowingly or unknowingly, of course, what you want to do is maybe create a micro frontend solution. And for this, you will usually, of course, go to much better patterns or more elaborate patterns. And one that really sticks over the year is server-side composition. So what is happening here is that the browser makes a request, hits a reverse proxy. This then knows, of course, that it's a micro frontend composition that needs to be stitched together. So it then calls kinds of different servers to get different elements. For instance, here in this example illustration, you see that server 1 holds kind of a template. This template has kind of a hole or a placeholder in there. And then some other server 2 in this case, serves the fragment that will be then brought in by the reverse proxy on the specific location. There could be all kinds of ways to achieve this. And you could, for instance, also rely on, of course, some kind of standards, for instance, easy edge-side interfaces, where you say, okay, we just use the standard easy tags, or the server side includes the SSI, and could also rely on those. But there are multiple ways, of course, to achieve this, and there are also frameworks out there that help you achieve this pattern. One of the problems of server-side composition is usually, what are you doing with all the JavaScript, right? Because at the end of the day, today's websites, they have at least a decent amount of JavaScript. Some websites, of course, they don't need any JavaScript at all. And if there is a little bit of JavaScript, it's usually not necessary. But most web applications that you consume today, they're either already single-page applications, so then this pattern would be really difficult to set up correctly, or they make use of some JavaScript. For this, of course, new patterns have been introduced. One is client-side composition, where you just say, hey, I use a lot of JavaScript, so wouldn't it be the best to already compose everything in the browser? There are multiple ways to do that here as well. One way is, for instance, you have all your micro frontends served as scripts. So your main page just includes the scripts, and at each script could then define multiple web components, so just custom elements, and then you could use the fragments that are exported from these micro frontends as custom elements, right? So they could be already in your HTML code that comes from the server, or they could already end up in whatever framework you're using. Nevertheless, quite often, of course, there are several downsides here as well. And so what you could think about is, hey, I still want maybe some client-side composition, but I want a stronger loose coupling, more dynamic approach. And what can we do here? So one approach that you could take is follow a pattern that's called siteless UIs, which works against a discovery service, gets all the micro frontends, and allows you to embed components, events, and everything scattered across all these different micro frontends, just in a single application, but also, of course, being really reusable and being also able to be reused in other applications as well. So that's just to give you a few hints in what direction this could go. In general, as mentioned, it's an organizational pattern. So the idea behind it is that you quite often can do a development approach shown like here. So one team is really responsible for having the grand scheme implemented. So this is denoted here by the app shell development. App shell usually being a phrase to indicate, well, now instead of having a full application, we just have, let's say, the hull of an application with all the real functionality coming in form of these micro frontends. Now, of course, you need to have a first version, but once you have this, you can already trigger development of these individual pieces of the individual micro frontend. So the team behind micro frontend A may already start, and then, of course, iterate on their own. And this is really what micro frontends are about, that this team is fully independent now, and they can just say, hey, I have a new feature, I want to ship it, let's ship it. Then the parts that are, let's say, made up from microfrontend A, they will all update. They still live in this application shell, right, that was deployed previously, but they just update, and there was no involvement now from the app shell team. There shouldn't be any. And likewise, of course, there might be other teams, and they also, of course, start the development. And most importantly, again, there really doesn't need to be any alignment or any kind of procedure when they deploy. So as you can see here, they are not really aligned. So version 1 development starts later, of course, of microfrontend B, but then, of course, it doesn't really at the same point in time deploy as, for instance, microfrontend A or also microfrontend C in this graphic here. Also, of course, when they deploy, is fully up to the team. So a team could say, hey, we feel really comfortable just deploying at the end of a sprint. Then we have everything finished, that we have some new functionality, maybe, or some bug fixes, and we just ship. Another team might say, we only ship when we have a certain feature ready. And the third team might say, hey, we only ship, of course, if management tells us to ship, and otherwise we don't even take chances here. But really, it's all up to the team, what the team feels most comfortable with and what just makes sense for the team, right? And this really being team-centric now and having everything that you need to ship something within a team, that is what makes up the beauty of microfrontends, and what is also the next step for microservices, which really are divided across, let's say, a service-based approach, where you still have these islands that are shared at the front, that most notably, but also quite often operations and especially the business area. And now we want to have all these different parts in a team that they can be fully autonomous. Now, quite often the question arises, what now specifically is a microfrontend? Is it just a component? Is it more? What is it? Well, a microfrontend can be essentially just sort of as a container. It could be the same as a team, but often a team could also have multiple microfrontends. So this is already maybe not the best way to think about it, but I always think about it as form of a container of components. And quite often a container that is already mapped to a certain subdomain of your application, such that when you say this is the subdomain, I don't know, we have an e-commerce application, we have a payment subdomain, then just everything that's related to this payment should be in this microfrontend, the payment microfrontend, right? And from there on, of course, there might be multiple components that are then used. So what are these components? Is this the same as a component library? It's not. Let's look at it. Here, for instance, we say the microfrontend is, again, e-commerce domain. We call it the orders microfrontend. So it should deal of the subdomain of making an order. What is all involved there? We have, for instance, a card usually, right? And this card potentially want to use in the application. This is what I refer to as a domain component. Why? Well, it might use, of course, and will definitely use in practical use cases. It will use something from a pattern or a component library, let's say an icon component or a button, I don't know. But then this is already enriched with domain information. So for instance, where do we now get from our system the information, what products have been laid into the card? Having this information combined with, of course, some visual gives us a component, the card button in this case, and is a domain component, right? Because, yeah, it takes domain information and uses this to already display something. So in this sense, of course, it's reusable, but always when we use it somewhere, it will just display what is currently in the card. If you want to have a reusable component that you can say, hey, now I determine what the batch number tells me or where it links to, well, this is no longer a domain component, but just a generic component. What we usually refer to as a functional component. So example here is, for instance, an icon button combines an icon element with a button element. And this even might be composed of different lower level things like atomic components, which in this case, for instance, could be a button or the icon, of course. And so you see there is this trail, and the things that the microfrontend exposes, or you could also call it exports, but it is not like a library, right? So it rather exposes, because it only can be used at runtime, are the domain components. And this is really what you should think of a micro frontend, just a container for domain components or other related domain functionality. Could be also receivers of events that then do something, etc. Right. So how does this look in practice? Let's check out some demo. Here you can see a small application that was done by an intern from us, I think a couple of years ago. And it essentially is a clone of Netflix. Netflix, the video streaming platform. We always like to use this example because pretty much everyone knows Netflix, so there's not much introduction needed. Netflix is also known for introducing microservices, which makes this a rather nice transition. So to say, hey, wouldn't it be good if they also use micro frontends, especially since the Netflix web portal, is a classic single-page application. So it really makes a lot of sense to have client-side composed micro frontends here for illustration purposes, right? Now, let me just reload this application just to show you the user experience. As you see, it's rather fast and it does everything there. So this little loading icon, it did all these things. It loaded all the JavaScript code, loaded all the micro frontends and the JavaScript code. It loaded the data that's needed to show here. That's live data, except I think the teaser here, the narcos, that is there since we came up with this example. But all the rest, the top TV picks and everything, that's IMDb data. So that's a request to the API there. Now, that being said, you might now not believe me that this is a micro frontend, but what I can do just to show you that, this is actually micro frontend based, is I can go into a discovery service. So we have a community service that's free to use called the feed service. And all the micro frontends that are used in this example are listed there, right? So one of these micro frontends is called favorites. I hope you can see that. I will make it a little bit larger here. And the favorites one, I can also disable. So this is a really hard button, right? So when I disable something, it will no longer be there. Again, let's look at the application. What is there that reminds us of favorites? Well, we have, of course, the favorites page. I have one marked here, but let's just unmark it. And I have the add favorites button for the teaser, and I have a little favorites icon for each of these movies or TV shows. So when I just bookmark the Tagesschau, which is the German news, daily at 8, I want to see that, right? So I now have it on my watch list, so to speak. Now, that being said, let me just disable that. So it's now disabled. If I go back, well, it's still there. What is happening? Well, of course, I didn't do anything with the application, so it is already loaded. It's already there. Generally, you could, of course, react to it dynamically. Wouldn't be such a nice UX, however. So what we are doing is just restart. Again, we reloaded the application. Now, the favorites page is missing, the link is missing here. We also miss here a button, and we miss, of course, our favorites that was showing there, right? So with the micro frontend gone, it is now completely gone from the application as well. There is, by the way, no if or anything in any of these codes that I have of these components. So they actually don't know that the other micro frontend exists. But by this architecture, if the micro frontend isn't there, no components from the micro frontends are there, so they don't register. If they're not registered, they will not be displayed. As simple as that. I can bring it up again. And actually what we could also do, but due to the also, of course, limited time in this talk, I will not do it. Maybe later if we still have some time left, is we could also dynamically decide if we roll out a micro frontend. And this could be rather interesting in a real world application, of course, because depending on the users that you want to serve to, right, they might have already privileges to, or let's say, I don't know, interest to see one or the other thing, which is bound to a subdomain, so to a micro frontend. And so dynamically, these discovery service could decide, hey, it would be good to also ship this micro frontend for this user or not. You could also do that, of course, and in demo purposes, we would do it like this, based on, for instance, the user agent. In Chrome, we would ship this feature, in Firefox not. In general, of course, I would never do feature flags like that, but they are really nice for demos, right? So you can easily see where the direction is going. All right, so keep this in mind, especially the user experience that we've seen, that we see this loading icon and that everything flows in. We could also now look into, for instance, the network tab and see all these requests, but we come to that later. For now, the only thing you should remember, this thing heavily requires JavaScript. Without JavaScript, it will not run. And we also have this delay in the beginning because everything needs to be loaded and come together, which might be acceptable, but might also not be acceptable. Right. This being said, how can we maybe solve all these issues with the JavaScript? Well, this is where another pattern comes in. And the basic idea is that if we can reduce the payload of the shipped JavaScript, we automatically increase performance. Sounds always good, right? We're shipping too much JavaScript, too much unnecessary JavaScript. And of course, reducing this, I mean, if we just can do that, why not? Essentially, this, of course, depends, as we've heard in the previous talk, it depends on the use case especially, right? So what kind of website are you doing? Now, this Netflix example already illustrates, well, here we will need JavaScript, so this will be definitely on the right-hand side, JavaScript me up. I want to have it. But then, of course, there's the whole left-hand side where we have only static things and maybe little sprinkles of JavaScript, but they're not necessary. Wikipedia would be here my favorite to mention. It's purely information-based. There shouldn't be any need to use JavaScript there. And again, there could be some, of course, enhancement strategy for JavaScript in these areas, but they're never necessary. And then, of course, there's a huge bulk of websites where you say, hey, I got a decent amount of JavaScript. And of course, it should be optimized somehow, but I shouldn't need to rely on JavaScript, and it should still go as fast as possible. And this is the area where we now want to enter, right? So where we also want to drag maybe our Netflix example too. Great. Island architecture. So what are they doing? What are they supposed to do? Let's take this simple example that I stole, to be honest, from Dino. So Dino is an alternative runtime to Node.js, and they also came up with a framework called Fresh, which is a framework following this island architecture. Now, what they are doing there is they have a little bit of a web shop, and the web shop is a good target for the island architecture because there you really want some JavaScript, but it should still be really fast, and you don't want to rely too much on JavaScript, meaning you don't want to wait until the JavaScript is loaded. You don't also want to bloat your users with JavaScript. So all you want to do is you want to distribute the sprinkles of JavaScript that they call islands of interactivity. You want to distribute them to the right places and maybe only load them, of course, when they are needed. So you need some kind of orchestrator. And the basic idea is to identify now these interactive areas. So you have, for instance, here the card. You have also this kind of carousel element for the images. And you have, of course, your button add card. That all is already very similar, of course, to what we've seen for the micro frontends example. There we also have kind of an orchestrator. But instead of now determining, of course, where to load the interactivity, this orchestrator just determines where to get the data or the component from which micro frontend. But still, in both cases, you need some kind of a decision maker, and it wouldn't be a nice framework if you are the decision maker, then you don't need the framework at all. It is really nice if this decision maker comes already with the framework. Now, there are other approaches, and the approach that Dino with Fresh took is using a hydration approach. So they call it partial hydration or progressive enhancement, of course. But still, all these little islands, they need to hydrate. And in case of Dino Fresh, they are written using preact. So you need to load preact first. There is also an alternative approach that was, let's say, embraced by a new framework called Quick, which I like really a lot. And we will see that we can also take, or copy that to solve our problem. And this approach is based on serializing the state that you, let's say, together on the server. So the basic idea is that when you want to reduce your JavaScript, you start with a server-side rendering, because what could be better than having no JavaScript, right? Therefore, of course, you start with a server-side rendering process. Now, if you now follow, for instance, what Dino is doing with Fresh, or what you could also do with Next.js or other frameworks, the problem usually is not the server-side rendering. This is quite well, and you just disable JavaScript, it all works. The problem usually arises in the gap then between the site was fully delivered and is now rendered to, hey, the site is now really interactive. Because, well, I mean, in case of Fresh, you need to first load Preact, and in case of Next.js, you need first to load React. Surely these are now optimized bundles, but nevertheless, they are certainly with some offset in there. And this kind of, let's say, gap that arises is really a problem, right? It is a problem for lighthouse scores, but it can also be a problem if you don't have such a good data connection. And if now, I don't know, loading 200 kilobytes in scripts really takes longer than, well, what you as a user expect it to. And especially on mobile, you don't see that it's still loading. You click somewhere or touch it, and it is just not responsive. So what they came up with is that you don't need to hydrate. You essentially already serialize everything, and you bring it already with your JavaScript, so that your JavaScript knows, by the way, this thing will be bound to an event handler, and it follows this the following string. So there is essentially already everything that you need to know for hydrating the components embedded within the HTML that's delivered. It's not a full hydration that just then looks up and, oh, matches then what's already on the DOM with what there should be, but it already then starts with what was seen on the server, which is, in my opinion, a really great approach, brings great performance, brings, of course, in the development of the framework complexity, but it shouldn't bring additional complexity to us as developers against that framework. Now, that being said, there will be more frameworks out there that use this resumable approach where you serialize the state, and the next version of Marco, which was arguably one of the first to have the islands architecture implemented, also wants to bring resumability to the table. Also, we have approaches like React Server Components, or what Astro is doing. All these are using the partial hydration, where you have your islands and they then hydrate at runtime, but they still need to hydrate. Sure. Great. So this is, in a few words, what the islands architecture is about. It's a pattern that is, at its core basis, technical. It makes assumptions that you server-side render, that you have an orchestrator on the client side, and that you are all about having these islands of interactivity that trigger under certain conditions. I don't know, when it's loaded, when you click, when it's in invisible viewport of the browser. So there are all these kinds of assumptions there. So it's a purely technical pattern, and it was implemented in a couple of frameworks. And again, micro-frontends on the other side, they are organizational. So the question is now, how can we use the knowledge that there are island architectural frameworks and how they're working together with, of course, our knowledge of micro-frontends? Well, let's recap for a moment what islands really imply. They imply server-side rendering. They imply to be minimalistic, at least from, let's say, the viewport of the developer. They usually come up with progressive hydration, even though there are other patterns. But let's say if we are independent of the technology, so React or something, if we take that out of the question, it has to be progressive hydration, because this pretty much works all the time. And it might come up with resumability, because resumability, well, we like to have it, right? If the framework supports it, like Quick or the next generation of these frameworks, then yeah, sure, give it to me. It will be better. It will be faster. And they also try to come up with some lazy loading, which means in case of no interactivity being used, there will be also no JavaScript being shipped, not even this kind of orchestrator. Even Quick ships an orchestrator JavaScript, right? you will still not see a script being loaded. And the reason is quite simple. It is so small, it's just a kilobyte, that it just embedded on the website. So it just comes with the HTML. And this is one of the reasons why it is also there pretty much from the beginning, because when the page was fully passed, the JavaScript was already included in there. So there's this orchestration JavaScript. And so it can just start on working. And there's not even a network request necessary to check, was this thing changed since the last saw it or something like that. It will just be there. But make no mistake, if you don't have any interactivity on the page requested, the orchestration script will also not be there. And you have, of course, placeholders in there too, and you can do all kinds of nice things with this. Microphones, on the other hand, they are usually distributed. That's the whole point of it. You might even develop them outside of, let's say, a single repository. So you could do microphones as monorepos. It's a very common approach, but there is no need to, right? You can have a separate team somewhere else in the world where you say, I don't trust these guys. They have their own repository. And it might be good anyway, because they make their own decisions, how code looks like, etc. They have their own CI/CD pipelines. Everything's awesome there, right? So fully distributed has to be embraced here. It allows proxies and, for instance, the server-side mode. It's all about the orchestration of these different parts. It's all about scaling development. That's a contrast to scaling performance, but doesn't need to be exclusive, of course, right? And most importantly, you also want to embrace lazy loading here, because if you just load everything that all the microphones bring, then of course you will be in trouble. You only want to load the pieces that you use on the screen. Quite often, microphones have been, let's say, tied to the thought of having a tech mix, because that was always one of the selling points of microservices. Hey, you don't like Go, then write your next thing with Rust, write your ASP.NET Core service, or use something else. And of course, you can do that with microphones, but you don't need to have microphones for this. You could have done this beforehand. It is a little bit independent of microphones. And honestly, it is maybe not the best way to think about microphones, because at the end of the day, I mean, if you have Vue, Angular, and React, your end users don't care, and usually it will not be better from the performance perspective. Plus, of course, there might still be the situation that then the team members that knew Vue, I don't know, they left, and so good luck getting in there, or the ones who were responsible for React left and no one else knows React. Well, I think having this coherent is better. But of course, it's good that you also have the option to have other things. There might be some points why you want to go there. Also here, we have placeholders to say there could be something else coming in. Right. So having said that, there is an intersection happening where you say, hey, but we've already seen from the patterns you can do server-side rendering. Since we want to have a tech mix, resumability is essentially off the table, right? But what we could do is we could still do progressive hydration, but we still need to have this whole thing in a decoupled way. So it must be at runtime combined, and we should have it that multiple teams can work on it in a distributed way. So if we fulfill these things, then essentially we can have microphones with islands. So the general way, what I will now show you in the demo, will look as follows. Let's just go through the diagram, and there we will see where resumability comes back to us. Because when we start now composing these microphones, we can't start, of course, in the client. Because if we start in the client, well, then again, we can't have a zero JavaScript requirement fulfilled. So what we need to do is we need to start on the server. It definitely needs to begin at the server. We need to grab the microphones that are there. So we start creating a state for the current request. We load the different microphones if they're not already loaded, so we know what components are in there and how to fit together. And then, of course, for this current request, we start to render something as we would usually do on the server, right? Now we take all the components that we find that were necessary to create this, and surely we know now where these components come from. Are they maybe already there from this app shell, or are they now originating from some of these microfrontends? Once we finish rendering, we serialize the state and we still put it in the HTML. We will need it at runtime later. And then we just ship that and it goes up to the client. Now, the client, of course, sees the HTML, it loads it. And on this HTML, we will, of course, also have a little bit of JavaScript. Except, of course, in the case where we don't have any hydration needs. But we'll come to that in a second. So we also have this loader there. We initiate it and resume from this point in time. Because again, here we took a look at what Quick is doing. And this resumability thing, I think it's good. We should have this whole information encoded in the HTML, because this way we can just start from there already. We don't need, again, to load microfrontends and see, hey, what have been there? Which of these microfrontends, components from the microfrontends that are on the screen now require the interactivity? No, no, no. We already know that from our whole rendering phase on the server, and we continue from there. Now, for instance, we might identify that component 1, it was fine. It may be remarked that should be only rendered on the server, so we rendered it. There was no remark for any client-side interactivity, so we just drop it. But component 2 might have remarked, hey, when I get visible or when I've loaded, please load the following JavaScript to make me interactive. So we just resume there and we hydrate it. And with this in mind, we're essentially done. We have the page rendered and we are on an interactive page, right? Now, let's go into a demo and let's do this demo locally, that I can also show you maybe how development against it looks like. Let's start this demo first. So here I have a code base and we can also compare it to the non-island version, but you will see that the structure is essentially the same. So from a development point of view, it has not changed so much. Let me just start everything here. And before I look in the browser, I will just show you this code base. And again, it is not so different to the other code base. If we would compare the two, they are essentially on a high-level point of view the same. So we have a couple of microfrontends. We have the browse microfrontend, the favorites, we have profile, we have search, and we have watch. So we have 5 microfrontends in there, and then we have an app shell. Now, the most crucial difference is that in this case, if we would compare it to the previous example that we've seen, the app shell is not just a single page application, but it consists of 2 parts. We have client and we have server, right? If we now would use a full framework, of course, the code here would be much less. I guess there wouldn't be any. But since this is written from scratch, I just have a couple of files in here in the client. And all these files just deal with reading out the state. I mean, essentially being this client-side orchestrator, right? Taking it and then doing this hydration, right? So that's why we, for instance, see here files like hydrate tsx. I don't want to go into detail, just to show you it's not much code, right? So here, for instance, it doesn't do a lot. I could also write it in a lot less space, but to have it prettified, as you can see, all it does, it renders via some kind of an updater component. All right, and this being said, we of course have our microfrontends in there too. So for instance, we have here the favorites microfrontend. I will go into the code in a second. Let's just first have a look at the application. And of course, keep in mind how the application previously looked. So we have this running on localhost 3000. So let me go in here, and we are on localhost 3000 now. Now this thing looks pretty much essentially like the previous one. I changed it a little bit, made it a little bit look more modern, so we don't see the spacings here, for instance, right? So they're gone essentially. But make no mistake, it's essentially the same application. Now, from the user experience point of view, if I reload this, you haven't seen any loading or anything, right? So I just reload and it just works. The other thing that might be important to remark, let me see if I can find it, is if I disable the JavaScript, let me do this, Firefox automatically reloads for me. This is nice, but I will also do it explicitly that you can see it again. This application still works. the loading of the image was now slower, but I think that's because now the network tab is open and I always disable the cache. But the thing is, this application is still there, it's fully present, and it's also working. So I could, for instance, log in, and I don't know what it takes now so long, but anyway, here it shows me this thing, and it, of course, is exactly what I would expect maybe from a standard application. Maybe I don't expect it from Netflix, but here I get it essentially for free, which is awesome, right? So it now works without JavaScript because it's fully server-side rendered. Now, there are still some things that are done from JavaScript that are otherwise not there, and specifically things on the title bar. So let me again refresh here. We see this thing, and if you look now in the title bar, you don't see the search. And honestly, we could also, of course, display this. But what the micro frontend behind the search told the micro frontend orchestration system is, I am only there if I'm only rendered from JavaScript in the browser. That could have different reasons, right? So this component only makes sense, for instance. Surely in a real-world application, you might still want to have access to the search. But here, I mean, for didactic purposes, we said, well, this might be a good case where we say it's too complicated to develop it without JavaScript support, so let's just not show it if JavaScript is not there. Which, again, is maybe a reasonable choice depending on what you want to achieve. Now, this in mind, we still have the same system as beforehand, meaning I could now do the following. Let me bring the code editor here and let me have it on the side. I still have here the entry point of the favorites micro frontend. And what I could do is I could just return early. Now, what this entry point is doing, it essentially allows this micro frontend to register or expose, you could also say, the different domain components to the whole system. So in this case, they, for instance, decided, the owners of this micro frontend, to register something in the menu, which shouldn't be hydrated on the client because it's really just static, or to register a full page, right? Or to register a so-called list toggle. I don't know what that is, but let me just tell you that it was used to actually have these list toggles somewhere. So I don't see it because I'm not logged in, but let me just log in as chain here. If I'm logged in, I see here these heart icons, right? And the add to favorites. Now I'm logged in and I see these things, and let me do the following. Let me save this. So it now updated, right? I didn't do anything in the browser. Now this one micro frontend updated, and essentially it doesn't register anything anymore. So favorites is now gone here, it is gone here, and it is gone here. So all these things are just away, right? This is the same as, essentially the same as what we did before and with the discovery service. Now for the debugging thing that runs locally, we don't have, of course, a discovery service in between. So it runs directly now on this code base. But nevertheless, it is essentially the same process. We essentially disabled the favorites micro frontend. We can, of course, bring it back, and all these things should be also there, minus some CSS issue appeared here. All right. So that being said, this is how micro frontend is developed in this model, right? And the components itself, they are, for this example, written in React, but they are not so interesting if you ask me. So, for instance, the menu is really just a menu. Important part, of course, is if you want to server-side render them, you want to support, of course, the non-JavaScript use case first. So you don't see, for instance, a React router or anything used in here. It's just a standard hyperlink. And then, of course, on the client side, if there's JavaScript enabled, there is a little script that jumps on it and says, hey, there's a link, and it goes within my system. So I just hydrate this and make it a single page application link so that we don't reload the full page. And this is how the whole thing works. Essentially, it takes away from you the whole burden of having to decide all these things and making it optimal. So you get the best benefits of the microfrontends, all the lessons learned in the recent years that have come up with, for instance, how dependency sharing works in the front end, right? That this is optimized, how loose coupling works, so this is optimized so that, for instance, things like this toggle, they work. Again, there is no remark somewhere that if a microphone is not there, we've seen it now. I mean, we just disabled it. It doesn't work. And the reason is quite simple, because we are using this as a kind of an identifier, like with events, for instance, where you emit something and you can have a listener, but if no one emits, I mean, you don't care, right? It's the same here. If you don't register, it's like not emitting something. So somewhere we have a listener where we say, hey, if there is something registered for this toggle, render it here. So there's nothing registered, so nothing will render there, right? It's as simple as that. So the whole model you take with you, the only extension to the standard model is that you now have, of course, hints that you can give, like client none or client visible, etc. You can also give server-side rendering hints. And you can, of course, work in addition with some data that you bring from the beginning on. And all this is evaluated on the server, carried on to the client, and from the client on, of course, you render it. The whole example is, by the way, on GitHub. Again, I don't want to go through all the code. It's not huge, but it would be, of course, longer than this session. I think it makes much more sense at this point in time to go into your questions and see what is there, what we could cover, to get most out of the session for you. And with that, I want to thank you all for your attention for the moment and hope to have some really nice questions now as well.
Florian, hello again. Yeah, thank you for the talk. You are right. We got some questions in. So I would say, let's tackle them. All right. First one. Great demos. Can you describe some basic instances where we may have used micro frontends already?
Yeah, so as mentioned, you can distinguish between the two cases. Building a whole micro frontend solution, I think this you would have detected. And the other case, of course, just using a micro frontend. And classically, of course, and with classically, I mean, I always learn that I'm now old these days. So I started web development in the mid of the 90s. And so the first things where we tackled is ads, right? And we had a great invention there, end of the 90s, the iframe. That is a little bit the successor of the frame element or frame sets that have been used in the early 90s when the web was still young. What iframes allowed is to have a whole document that's completely on its own, rendered inside your document, right? This is really great for many use cases, and one of these is ads, where you say, hey, I don't trust these guys, but still I want to have this thing shown so that they also, with the server, get notified that someone was, of course, viewing my page and was viewing the ad, and I get some revenue coming in. And so ads, of course, is one of the things where you might have already used or will definitely have used iframes, knowing or unknowingly. But then many other things, third-party services, some of these cookie consent dialogues, for instance, or the chatbots, right, that open a little speech bubble on your page. While there are, of course, some third-party services that develop that, I don't know, running in your web page, most of them, all they do in your web page is open an iframe. So quite often the process is as follows. You embed a script element somewhere. In the script reference, you might have, I don't know, a special identifier that says, I'm this kind of user behind it, so please load it in that language, or I don't know what, with these settings. And then, of course, this script goes ahead, makes a little bit of API requests, but it also opens an iframe. And they do that to get a styling isolation and a lot more isolation. They never conflict with whatever you have running on your site. And this is, I think, a great use case of micro frontends, because, I mean, if you think about it, these third-party services, they are third-party, right? So they're not your team, and they also don't want to rely on you, and you don't want to strongly rely on them. So it's an ideal use case of third-party service, and of course, of using a micro frontend to transport it. I mean, we now label it micro frontend, right? But yeah, this iframe approach, it exists for quite some time already.
Yeah. Makes sense, Florence. I might also have an example for an iframe. For example, all of you that attend the event today, you subscribed via a form on our website. That's also an iframe.
And that can be developed completely independent, right? And updated there. And then this form, without you touching the main page, just got also updated, right? Which is what microfrontends are about.
Perfect. Thank you, Florian. We have another question. How does island architecture impact critical aspects like accessibility?
Yeah, so I mean, there we need to distinguish also between two things. So the first is, I think, general accessibility. So regarding, of course, that you have semantic HTML delivered and all that, and that the search engine optimization and everything, that, you know, the page itself from the content it serves is, let's say, available on a broader scope to the more clients, is tied to server-side rendering, right? So therefore, island architecture is usually a benefit there. Now, regarding the real accessibility for your page, now targeting, for instance, things like, is it really accessible for the keyboard, or you know, are the colors in a good scheme and things like that? There, I don't think it helps you, but it also doesn't, of course, prevent things. That's still, of course, in your hands. You can, of course, always decide if, I don't know, you make a drop-down element in there, that it just works also, you know, if there's JavaScript disabled. But of course, you could also say, well, this dropdown, it has a lot of functionality, you need a lot more JavaScript, it needs to be interactive, sure. But then again, we're not, I mean, island architecture isn't here to help you in particular on this UI component, right? You still need to have all the accessibility hints, your arias, etc., to have it really accessible. And therefore, I would say it doesn't impact it in neither a negative nor particular positive way. It still leaves all these areas up to you. But then again, I would say just to have a broader scope of clients reached, it helps you in this regard, which could be regarded as an area of accessibility.
Right. Thank you for clarifying that. Let's jump to the next question. First, great talk, Florian. How can I develop locally with a multi-repo approach?
Mm-hmm. So there are multiple ways to tackle this again, depending on what, I mean, in general, you should always try with a microfrontend solution to have it set up in a way that multi-repo does work. Now, there are certain approaches that I would say make it more difficult than it should be. But if you follow the approach that I've showcased here, that out of the box works in a multi-repo approach. How it does it is as follows. It doesn't assume, of course, that there is always a certain combination of microfrontends running, which is the basis of it all. And the second thing is that your app shell, so the thing that, you know, has a technical foundation of your solution, well, this can be also shipped in form of an npm package, for instance. So this way you could just install your emulator, as we call it, so your app shell locally, and using this emulator, which we call, because it is very similar to how you would do, I don't know, Android or iOS development, right? So there also you can develop independent of Apple or independent of Google and independent of a specific phone, you develop locally, right? And you do that because you emulate the underlying system where your application will be running. So you should set up a system like this as well, because then in whatever repository you're using, your own repository, of course, you just install it as a dependency and you just run against this thing. So you start your instance of your microfrontend running against this emulator. If you want to know more, there's also on the Pyrel website. So Pyrel is a framework that uses this approach quite heavily. So it uses this since many years. And I think it's a very successful approach if you develop microphones in this kind of plug-in way where you say you have your app shell and then you want to have all your microphones loosely coupled just living there. Because this way you can just do that.
Thank you for that answer. And yeah, you just mentioned a framework and how fitting for the next question, because one of our viewers wants to know if front-end frameworks are used in island architecture. Should all islands agree to use one, or can different frameworks be used?
So this is also a great question. The tech mix, of course, as we've heard, is one of the things where microfrontends was hyped about. Personally, I'm not so hyped about it, but it is, and it should be a crucial cornerstone that you can opt into, right? And this being said, it also must be one of the things that should be allowed, of course, using the islands composition or island architecture combined with microfrontends. Nevertheless, if you have the option to rely on a single framework, just go there, because like with no island architecture, it gives you the best possible performance, right? Just taking the example, you have two components, both should become interactive. One is, I don't know, from Angular, another from React. You will still need to load a lot of Angular. Now, even if this is using AOT or some other compilation mode of Angular, it will still be heavier than, of course, using nothing. And the same with React. It also needs to load some runtime, right? And if, for instance, both are developed, let's say React, then you need to load this runtime just once because they can share this runtime. The actual code, of course, of these components will not be shared, but you would only need to load it once. Under the circumstance, again, that both need to become interactive. If only one of them needs to become interactive, then the situation is, of course, a little bit different. But already thinking that you have multiple technologies and you have multiple use cases, then this thing will certainly arise. And less is more in frontend quite often.
Very wise words. Thank you, Florian. We got another question from the audience. Do you have an idea of the impact of island architecture on SEO?
Yeah, so in general, of course, every server-side rendering pattern will have up to some degree a positive impact. I say up to some degree because there is a common misconception that if you use a single-page application, for instance, then Google will not see you. This is not right. Google uses since many, many years Google Chrome as in the crawler. Since I think 2 years, it's always the latest version of Chrome. Beforehand, it was always pinned and remained for a couple of while. So they will see it. But nevertheless, there are still two things. So the first is the initial rendering will be faster. And faster is also one of the metrics where Google ranks you. So if the O is optimization in search engine, right? And you want to be ranked higher. Therefore, look at your metrics, try to improve here. Server side is usually better. And the other, of course, is it makes it easier for you to have semantics properly covered, right? Because, I mean, you see also the HTML that's generated. And what Google also likes is if it can detect a structure and make sense of your code. And this, of course, gives you not, oh, I don't care what the HTML looks like because I'm anyway doing a single page application, but you optimize already in that area. And you usually come up with something that's not only faster transported, but also, of course, makes more sense to the crawler. So you get a lot of more points. It doesn't mean that sparse are generally worse. So there might be exceptions to this, right? You can always be a good developer and follow best practices. It just makes it easier to rank higher out of the box. And I think this is what we should aim for.
Thank you, Florian. And we have time for one quick question. And it's quite fitting to your first part of the answer about the performance. What are some things to avoid when implementing islands architecture, especially when tackling performance optimization?
Sorry, it's a quick question, but it opens, it could be another talk here, right? Let me see what I can come up with in a 30-second answer.
I give you 40.
I'll give you 40 things to avoid. I mean, I think what I answered before, it would be the number one thing to avoid. Avoid going for more, for instance, more frameworks. There's always things you could add, of course. Here we've seen there is this little thing that takes over when it's on the client. It transforms, for instance, all these URLs that they have a single page application. There are so many things you could try to come up with, but try to really limit it. Because if in the end you either from a framework that you take or from an own approach that you tackle, if you come up with a solution that then has more bloat than beforehand, you will not be happy. So really try this to find your zen have less. And I think this will be in just a really short time the number one thing to follow, or to avoid to have too many things covered by this. Really stick to the basics.
Maybe we can talk a bit more about it on the next live day, on your next talk.
We'd be delighted to.
Florian, thank you so much for shedding light on some of the things we learned from you today. Thank you so much for joining us again. And hopefully, yeah, we see each other on another live day and maybe talk about performance in island architecture.
Maybe. Thanks, Beni, and everyone have a great day. Thanks for having me.
Thank you. You too, Florian. Bye. All right. And we jump right to the third speaker of the day. He is Senior Solutions Architect at AWS, is a strong advocate at Agile and DevOps practices, is a trained and also experienced speaker, and with his 20 years of experience in the field, he certainly knows what he's talking about. Very welcome, Alexander.
Thank you very much, Ben. Happy to be there.
Yeah, very happy to have you, Alexander. So before we start with your talk, would you mind giving us some details in 1 or 2 sentences what your topic is all about?
Good question. And we will also have a talk about micro frontends in this session, but coming from a slightly different angle. So micro frontend architecture, there are different ways to do this, but what we will see is much about interface contracts and how to use this for modernizing legacy applications.
Okay, awesome topic. So then I would say, Alexander, without further ado, stage is all yours.
Thank you. You see my presentation? Okay.
Yes, we can see it.
Okay, thanks. All right, so thank you for the introduction. Indeed, I'm Alex, a senior SA from AWS, and we are going to talk about interface contracts and micro frontend architectures. And imagine you are a web developer on a monolithic legacy web application, and it is tedious to continue developing it. And one day you think, can't we just throw it all away and start from scratch, right? And when you take this idea to your CEO, you may be greeted with a range of reactions, but enthusiasm will usually not be among them. And why is that? Because for a company, for a business, throwing away a perfectly fine application is literally burning value and taking away a proven solution away from customers. But also from a technical side, it might not be the best idea to throw an existing solution away and start from scratch, because you will make mistakes, you will make wrong decisions, and you will have to learn as you go. It might be that once you're done or have some sort of maturity, you have to start from scratch. Therefore, incremental modernization might be the way forward that makes both developers and CEOs happy. So, as you have heard from Florian, and probably most of you have heard the term microfront in recent years, there are very different ways to approach this. We will see a flavor of this technology in play today. And I will start with discussing a view of the architectural traits and why they are there, go through implementation, and then look at what interface contracts mean in this context, right? So, when we look at where this all comes from, we can look at a more, I would say, traditional microservices architecture. And you could imagine there's a huge organization building this e-commerce platform. You might have a microservices architecture in the back end that is exposed through an API gateway or a GraphQL layer. And then you would have some sort of front-end monolith on top of that, right? And for the backend, it works nice with the decoupled architecture, but in the front end, you have a problem, because while you have this alignment with domain concerns in the back end, everything you want to develop and deliver as a customer value has to go through this front-end monolith. And you might argue, okay, my front end, it might be monolithic, but it still is modular, and that is true. But there's still very tight coupling in terms of choice of frameworks, CI/CD, and also runtime state, right? And we should also not underestimate the complexity of frontends, right? Some people will argue, okay, frontend is just a layer of eye candy on top of our actual business logic. But that's not the reality. In reality, front-ends hold a lot of business logic, a lot of value, and this is where the actual customer interaction materializes. So if you think about how painful it can be to deliver a value when you have to go through a monolith, you may be thinking, why don't we replicate the patterns we have in the backend in the frontend as well, right? And this would be a way of building micro frontends, so to speak, with microservices. You would keep the backend architecture as is, microservices with some sort of API layer. And you would say, let us decouple the front end into distributed little services as well. Instead of an API gateway, what you would have on top of them for integration is an app shell or integration layer, host page, whatever you call those things. It's a place where these modules come together and create a coherent experience for the user. Now, this is certainly a step in the right direction, but we still have a problem with alignment. And this is, we still have to go through a backend API layer, and we don't have guaranteed alignment of backend capabilities with frontend capabilities. So why don't we just go full vertical and throw away this API layer? And this is another variant of a micro frontend architecture. And you could say this is a microservice that has a frontend, right? It's a full stack application, a full self-contained software artifact that runs in isolation, so even at runtime, but we would be part of a larger application. And now you probably already know a few things about building micro frontends with server-side integration or with client-side integration. This is a pattern that we will show with client-side integration, but from a architectural perspective, the main takeaway here is that you would have a full verticalization of the solution and have autonomy in a team to deliver that aspect of the web application autonomously. Okay. And once we do this, you will see that we now have full alignment of a part of the website with the business domain and the team that is responsible and can deliver this end-to-end, right? We still need that little integration layer or app shell, whatever you want to call it, but this is a purely technical aspect to orchestrate and integrate the micro frontends. In the reality, what you will have in larger organizations and larger enterprise architectures is something that is a bit more complex. And you will see that the web application might just be one part of the tech landscapes. And you will not have everything in the web application. So for instance, databases or very deep domain logic will be in other parts of the organization. And you cannot fully verticalize there. But you can still say, in a sense, web application is its own scope, its own domain. And you would say, this is the place where I do micro frontend architecture. And then I can use other areas of the enterprise landscape to get data and or send data, right? And if you look at this, you might wonder, okay, isn't that still a kind of layered architecture? But it's not, because you have it very strongly decoupled, both in the vertical sense, because you don't have a runtime hard dependency on these gateways. And at the same time, within the web application, you have a strong decoupling across the verticals between themselves. So you have highly autonomous teams that can deliver these capabilities themselves and run them as part of a larger application. Now we have seen the architectural patterns that you can apply here. Again, there are different perspectives on how you would build this in practice. But now let's look at the interesting aspect of how bringing this together and how to kind of slice this to see what are the right size of building blocks. And this is the question of composition. So we have now seen how a platform would look like, but let's look at the front end, how they would look together playing in the user interface. So here would be an example page of a flight booking. And you see here a search box on the top. You see some filter settings on the left. And in the middle right, you see a result list of flights, right? Now, this is an interesting discussion I had with different roles and organizations, with product owners, with testers, with developers, with ops people. I say, what is the scope of a microfrontend on this page? How many microfrontends are there? And the interesting thing is you get very different answers. And the reality is there is no kind of strict right and wrong how you would put this into one or multiple microfrontends. But you can use some guidance here, and you can say, where are the boundaries of the logic of such a component, right? And this is actually the million-dollar question. Where are the context boundaries? So you might know the term bounded context from the paradigm called domain-driven design, or DDD. And this is very helpful at identifying natural boundaries between independent contexts that can be deployed independently without too much coupling, right? So you can think about non-functional aspects such as reusability, performance, security, to structure basically this application into micro frontends. And there's also one other very, very important indicator for coherence or coupling, and this is communication patterns, right? So if some elements in your architecture need to talk a lot and exchange complex data structures, then it is an indicator for them to belong together. So this is still no pattern to make a right or wrong choice of what belongs together, but you can use that to make this decision. And when we look at this example, we could say, theoretically, why can't we say the whole thing is a micro frontend, is a single micro frontend, and we deliver it as such? Would be more coarsely grained, but still a valid answer. The entire opposite would be, we slice each of those components into individual micro frontends and deliver them independently, and then have more work on the integration side. And for the purposes of this talk, I will pick the middle ground and say the search will be one micro frontend on this page, and filters and results combined will be a second micro frontend. And I would justify this choice with the observation that filters don't make much sense standalone, right? So why would you develop them independently? You could deploy a filters plus result list on one page, for example, as a landing page. You could even have a toggle to hide the filters. And at the same time, you could also deploy the search bar independently and say, okay, I have this as a landing page, and it will lead to something different. Right? And the filters and results have to communicate a lot and very complex information because they need a lot of shared logic, whereas this coupling is not as tight between the search and the result plus filters. Right? So this is why going forward in this presentation, please keep that picture in mind of a search form and a result list. Okay? And keep in mind that when you decide how to slice your current architecture or a future architecture into micro frontends, there is not necessarily a right or wrong, but you will have tools like domain-driven design help you make the decision. Now let's look at the implementation of such a micro frontend, and we will specifically look at aspects of integration, interaction, and communication. So what you see on this page is a HTML code of a very simple web page with micro frontends. And now you might wonder, where are the micro frontends, right? And they are exactly here. These are so-called custom elements. And some of you may have seen them. For those who haven't, you see here 2 orange boxes, and each of them containing 2 lines of code. The first line of code is a so-called custom tag. So this is an HTML element that you can define yourself. And this is actually standardized. All modern browsers support this. I think the last that didn't support has kind of been deprecated since a few years with Internet Explorer. And you can use this in everyday web application. You can do this entirely frameworkless. And this is going to be what we're going to show today. In order for this to work, you have to define this custom element in a piece of JavaScript, and we'll see that in a second. And the second line of each of those orange blocks is the loader for these JavaScripts, right? On the right-hand side, you see structurally how this would behave within the web page. Now, if we zoom into those individual JavaScript files, you will see something like that. Again, some of you may have seen this already, and for those of you who know frameworks like React, this may even be familiar to some extent, but let's go through this step by step, right? So this is a custom element, starting with the definition of a custom element with the custom elements define API that takes two parameters. One is the component name, so what you see on the left-hand side in HTML. And the right hand, and we're doing this inline here, is defining a class that derives from the global HTML element class, right? So this whole thing has, as you already may see, a few, contains the actual HTML here. And again, this is quite familiar to people who work with component frameworks such as React. And you will also see that it has several lifecycle methods that would be able to register the attributes of this component and then later interact in the other direction. And these attributes that we have here, they are crucial for this approach because attributes in our case are the incoming interface through which we interact between the host page and the micro frontend. So this is a very important design consideration because similar like when you design a REST API or anything else that has to interact with the consumer that you don't control, you need to be very intentional about which kind of properties you would define and which kind of parameters they take. You would want to put some thought into validation, and you will also need to think about lifecycle management, right? So this first orange block on the right-hand side, the static observed attributes method, it will statically return the possible attributes that this component accepts. And the second block would be the runtime listener to changes on this attribute. So this means we can interact with the component at runtime by changing attribute values. Okay, keep that in mind. Now for outgoing communication, we can use custom events. So this is an API that should also be known by web developers these days. So you are very familiar with click events or hovers. But here in this case, we are using the custom event API to create our own synthetic event, right? So you see this payload of detail where you would put the actual semantics of the payload, and it has this bubbles and compose attribute that we need because in these components, we are using a so-called shadow DOM, which is a kind of encapsulation that will protect the internals of this component from being interfered by with the outside. So this is the way to communicate from within the component of the micro frontend in this case with the host page. Okay, so when we talk about APIs, we have incoming and outgoing ways of communicating, and this is very well suited for an event-driven approach, right? This is not synchronous, but you can have things going in and then literally react to them, throw an event, have it being consumed again, and then interact between the components on your website. Okay, so when you do this, when you throw an event out, you will see that you have dispatched this event. And on the left-hand side, again, you will see that we are using one attribute that's called language, right? And it could be other attributes as well that are more domain-specific, such as in the search form, you would have something that configures the maybe the layout or the form fields that are shown. And we will later see how we can influence the result list. So the initial configuration is placed there when the page loads. So however you deliver that page, it could be through static site generation or handcrafted, or I don't know, maybe when you come from a legacy world, it could be delivered through PHP. You would place those elements there with an initial configuration. And in a second step, you would also create an event listener there on the host page that would be able to catch those events that are, for instance, triggered by submission of this search form. And now you see here in lines 16 and 17 that we will catch this event and propagate the event payload or transform it, if necessary, into the search form. So the search, in the result list, the search form and the result list do not communicate with each other directly. because this would create a coupling between them. They would have to know that they are there mutually. You would expect that they have a certain way of communicating, but this would then take away the opportunity to deploy them independently. So what you do here is you just throw an event to the outside, let it be consumed by the shared host environment, and then forward it to the actual consumer that needs to change its state then, right? So, oops, forgot to change this. Now, you see here that we have the attributes that are the payload for the search form, and this would then create the new state of the search, meaning that it would know which flights to pick up and then to show to the consumer. Okay, so this would update its configuration of attributes, and then through this listener on the attributes, it would update and pick the flights from the back end and show it in the front end. Okay. Now, you see here that when you do this, you could imagine, and if you actually look into the dev tools of a browser, you will be able to see this happening. You would update these attributes, okay, picking up the from the back end. So this is the technical implementation of how you would interact between two front ends using the host page and events in there. But the problem with that is this is not standardized. So if you want to have independent teams delivering these micro front ends and then having a coherent web experience and expecting this to live on, to evolve, you need to have some sort of contract between those structures. And this is where there's a little standard called OpenMFE. This is an open source project. It's not affiliated with Amazon in any way, but this would help you to define those interface contracts, to test them, and to publish them within your organization. Okay, because in the end, when we have a distributed architecture, we want to give autonomy to teams, but we need to avoid anarchy. So when you look at this OpenMFE standard, that is a implementation that gives you a specification. So how should micro front ends behave at runtime? It would define how they would avoid sidestepping these standards. It would tell you how to formally describe these contracts, and would give you, similar to the Open API standard, a manifest structure. Together with that, you have some tooling. For instance, you can then test those contracts. You can see that, or to some extent, you can test that they don't violate those principles. And it also comes with extensive documentation of best practices, so you can then see how to build this in practice. So coming to the first point on this is the runtime governance. And you might wonder, okay, why do we need governance when we have contracts? And the reality is, as all those things meet in the browser, we can theoretically bypass some of those provisions and create a so-called side channel. For instance, if you have such a micro front end, theoretically, you have access to the host page and could inject CSS. And that's often the first, so we have built this in practice, and this is the first kind of idea that developers have when they need to fix something on the host page because there's some collision of CSS. Just modify the host page, overload some CSS, and everything looks fine. Of course, when you do that, you are breaking those boundaries and you influence the behavior of a component that doesn't belong to your context. And while this is technically possible, it's not desired in such an architecture. If it's an issue, then of course you need to talk to your peers and address this in some other way. But in the scope of the micro front end, we need to prohibit this and govern this, right? So what we do is we document ways of how to avoid this, and we are able to test some of those things, not all of them, to be honest, to make sure we do not create a mess by inadvertently breaking the boundaries. Okay, so if we forbid those side channels, what are the actual interfaces that we want to communicate through? And as we have already seen, a major part of them are the attributes and the events, and these need to be defined and to document it. So For those of you who have designed REST APIs and the likes, you know the Swagger or Open API standard, and this type of document may come very familiar to you. This is an own standard, and it has its own JSON schema, although this is YAML, obviously. But it is, from the idea, it's very similar. So you have some meta attributes that would describe the component for human readability. It would have an icon, some image, reference to documentation as markdown, things like that. And this will make it easy for you to document this in the developer portal. So you can import those things, and once the component updates or the microfrontend updates, you can also update documentation. You will have a nice catalog of microfrontends that are available, and you can use different parts of your architecture. But there's also the parts that define the actual heart, so to speak, API of your microfrontend. And it starts with the tag name, because that is the first part that constitutes a contract between the host page and the microfrontend. The tag name and as well the frontend part, you can have pre-rendering in order to optimize for SEO and things like that. But this is optional, and there are a few more things that are not seen on the slide, which would be able to have a more elaborate solution, but are not crucially necessary for each microfrontend. Now, if we go into these attributes and events, these are also the hard core of the manifest, and these are obviously the largest parts because they allow data structures. In an area of attributes, you might wonder, okay, usually you can only define scalar values such as strings and numbers in an HTML attribute, but this specification allows this also to be serialized JSON. And this allows you to have more complex data structures in attributes. Ideally, you would not use necessarily JSON, but would have them normalized in some way, shape, or form. But you have situations where you need to make several attribute changes at the same time, or you have more complex data structures like arrays or objects that you need to pass into a micro frontend. And this is a very straightforward way to define them. And on the event side, it's even easier because events naturally are data structures, and you just have to formulate them and define them through their names, through the constraints that you can express as regular expressions or predefined values. And then, of course, you would also have some description, which you can then render out in the developer documentation. So you see here we are using JSON schema within the event structures and the attribute structures. And you can use all the things you would have in a classical JSON schema as well. So this uses version 7 in the default implementation, but we will soon update this to use the most recent JSON schema specifications. So this is just a quick glance at the project itself. So it has a website, as I mentioned already, with a lot of documentation around this. And there's a GitHub project or a GitHub organization with several projects that provide some tooling, because what we're discussing here is barely scratching the surface. So if you want to look into what you can do with this in practice, you will find code samples and more code that you can have a look into. Okay, so this has been a technical deep dive into how this works. Again, the implementation we've chose here are native web components, frameworkless, but you can do very similar things if you choose to go with a framework. You could, of course, use the usual suspects, but there's also frameworks that you can use for custom elements, such as, let's say, just to name a few, Stencil or a lit from Google. So, but now the question coming back to the beginning of this presentation is, how can we use this to modernize a legacy web application? And you will usually start with this current state and wonder, what can I do with it? You have a lot of capabilities, and usually when you look at it, like literally having a look at the composition of the singular web pages, but also through the flow and through the areas of the whole web application, you will be able to identify things you can extract, right? Again, using approaches like domain-driven design, say where's a lot of cohesion, where are the communication flows, and then you can identify what would be a good candidate to build into a micro frontend. Because ultimately, you already have your new website in mind. And even though in this picture it looks structurally very similar, you might want to rearrange a few things, but you want to retain the value that is encapsulated in the things you have built, and then later maybe carve out the ones you want to modernize. Okay, so this is the chance to transfer what you already have in smaller, more interchangeable parts without having a big bang approach. So you might be familiar with an architectural pattern called the strangler fig. And this would mean that you encapsulate capabilities that you have and just use new interfaces to expose existing functionality, and then gradually change the implementation behind those new interfaces. And this is exactly what you can do here, right? So you would use your existing page and start building new capabilities as micro frontends. Or you can use existing capabilities and wrap this kind of custom element around them and deliver them standalone. The good thing about this is very low risk because it's basically existing functionality. It does not introduce new technology because what you have there works in every browser that people use these days. You will have, of course, the challenge that you will have some duplication at first. You need to find out how you can decouple the state of the existing website from the state within the micro frontend. But once you've gone through this exercise 1 or 2 times, you should have all the tools at hand to move forward without creating too much disruption in existing application. Okay, so with time, what you will see is you have lots of those capabilities built as kind of a backport into your old architecture, but you will also start creating new micro frontends that will be able to go through a new website. And you will be able to modernize the micro frontends that you have carved out of your old architecture and replace them with new capabilities, maybe clean up the code. And step by step, what you will have is a new website that runs those micro frontends, but you can also take those micro frontends and keep them running in other websites and legacy websites, because as we've seen, these are super portable and can run in different contexts. So this would be, in a nutshell, an approach to modernize your legacy application without too much disruption into something that is a modular distributed front-end architecture. So just one word of caution here. When you start moving into a distributed front-end architecture, and this is regardless of the framework you use, you will want to invest time into good UI library. Because what we have seen is that people start sharing assets, CSS, but also images, icons, and things like that from the host page into micro frontends. And the problem with that is, if you do that at runtime, is you create tight coupling again. And there are several anti-patterns where you would take the approaches that you know from building a monolithic application into distributed architecture that will undermine the benefits of distribution and not let you have the kind of benefits in the long run. So UI library is one example where you need to invest time, maybe have even a dedicated team that builds out those things into a library, and then lets those micro frontends consume them individually. Okay. So this is, in a quite short time, the idea how you would do that in practice. I thank you for being with me so far. I would appreciate your feedback. So if you could scan this code and answer 2 or 3 questions, how you like this session, I would be very happy. And then I guess we have some more time for questions and discussion.
Hello again, Alexander. Yes, there is still some time left for that. So yeah, thanks for the talk. And I would say, let's tackle the questions from the audience. So first one, how does the frameworkless approach align with modern best practices for front-end development, like component-based architecture?
Again, so when you start building any kind of architecture, you make trade-offs between the technologies you have at hand. So what is your outcome you want to achieve? Are you going for highest performance? Are you going for strongest cohesion? Are you working in the constraints of modernization and migration? In these areas, you have other best practices, or let's say best practices that fulfill other needs. When you look for components, they create a very tight coupling between these individual things, and you might not be able to develop individually. You could look at, for instance, module federation, which tries to bridge the gap, but it may be difficult to introduce that sort of, let me call it, advanced management of components into a legacy web stack. So yes, we are probably not optimizing for a few of the best practices you would have if you could build from scratch, but this is intentionally the case by using the possibilities that you have browser native.
Thank you for that answer. Let's tackle the next question. Is it possible to use the API contracts to test if components can interact with each other?
Yes, probably you would have to build some of the tooling yourself, because that would be more of an integration test where you see if, as I said, you do not want to have components talk to each other directly. You should always build them in a way that they are autonomous and just expose events and accept events, not knowing who it is. So when you talk about testing how contracts or the integration through contracts works in your environment, you would build a little integrated environment and test the flows within there. What you want to look at when you test is not necessarily the fulfillment of contracts itself, because you can test that in isolation. You could create a mock where you play with, you set up a environment that creates mock events or waits for events to be produced and look for that. But what you would probably focus on in the integration test is race conditions, or does a flow of events lead to the user experience you intend?
Mm-hmm. Thank you for clarifying this. We got another question from the audience. How important is it to test and check the parts of a micro frontend project regularly to make sure they work well together?
That's a very good question. So that's almost an organizational question, but we can learn a lot from microservice architecture here. So in terms of architectural approach in general, this is very similar, and applying those patterns makes sense. And when you build microservices, you will also make sure that, for instance, if you look at the API layer of distributed architecture that integrates everything, that you still have coherence over a business domain. And the same is true here. So you would probably want to create either a fully integrated version of your application with at least a coherent set of micro frontends, and then you would build functional tests against them. So it is, of course, very important. It is, in my opinion, much more important to focus on integration testing in a distributed architecture in general than on things like unit tests, because those things, when we talk micro, they have very little internal logic, and this may change a lot because, and it is not really relevant to the functioning, or it is relevant but not as crucial to the functioning of the overall experience. But many more things can break at the integration points of events, of APIs, and so you have this paradigm of a testing diamond rather than a pyramid. And this is why I would stress the importance is much more on this layer than on having a high test coverage unit tests.
Okay. Thank you for clarifying all of this. So we had an AWS question in an earlier talk. I don't know how familiar you are with WebAssembly. I will just ask straightforward. can you use WebAssembly in AWS Lambda functions?
Oh, that's a good question. I've actually been playing with this. The answer I would give to you is the AWS Lambda APIs, to my knowledge, currently don't support Wasm. They do support OCI. So the basically what Docker came from, you can run Docker containers on there. However, it does not support, and this is off the record, right? So needs to check later on. But from my current knowledge, you will not be able to run Wasm containers under the OCI standards. Would technically would be possible, but is currently not supported.
Okay, I see. Thank you. You really helped us out here, and Rainer, our first speaker today. Because I was saying to him, hey, we got a AWS speaker later. Maybe he can he can help us there. So thank you so much for this as well. And we move on to the next question. Can you combine the interface contracts with modern web frameworks?
I would have to ask a counter question. Can you give me an example of a web framework you have in mind?
Okay, then we save this one for later, and maybe the person will tell us something more specific. And in the meantime, let's tackle the next one. How do we make sure that interface contracts are safe from unauthorized access or changes?
So when we talk about unauthorized access, this can be read access or write access. For write access, obviously, I mean, the contract should live in a Git repository, and the Git repository of an organization should be hopefully secured against unauthorized modification. The interesting question is read contracts, read access to contracts. Should that be restricted? If there is confidential information in the semantics of this interface, again, this is very similar to REST APIs, you would want to protect it. At the same time as it happens in the browser, it will be very hard, because if you want to look into the communication flows, you can debug that from a live site. Again, very similar to REST APIs that are consumed through a public consumer like a web page. I don't see this as a big problem. So in fact, I can give you an example. So the things I've talked about is something that we've built during my time at a company called TUI, a German, very large travel company. And this is a success story, right? Because a lot of transformation has gone through this approach. And we have said we can document this publicly. So the interface contracts, the communication flows are something that we are very proud to show. And there's nothing that you can kind of exploit. Not in another way than you can exploit every website. You can scrape the website. You can DDoS it. Things like that will always be possible to some extent. And you need to protect yourself at a different layer than just concealing API access.
Mm-hmm. Makes sense. Thank you so much, Alexander. Next question. Any best practices for monitoring and troubleshooting issues in a frameworkless micro-frontend architecture?
Again, I would need a bit more precise, or let me maybe make some assumptions about the nature of the question. Mm-hmm. So I assumed you can address this on two layers, within the micro-frontend itself and on the integration point in the host page. But the mechanics are not very different than what you would have in a traditional web architecture. You would place your tracking tools inside the scope where you have them. You would log out the events that you have and then see for a trace. You could do this with very simple tools like console log, or you can use more elaborate tools from vendors that you may know. The thing to be careful of is that you will not want to break the boundary when you log those flows, because this encapsulation is intentional, because you still want the portability and autonomy. So what you will be able to do is emit analytics events through the host page, and let a host page do the tracking. So this is one pattern that has been applied successfully in practice. So instead of logging or having the logging capability built into the micro frontend, and the same is true, by the way, for user analytics purposes. expose those events, give them their own namespace to make sure they don't interfere with other events that you want to consume, and then let some handler log them away into your web analytics tools or your technical monitoring tools.
All right. Thank you for this answer as well. So, Alexander, you are already a senior solutions architect. You have 20 years of experience. May I ask what got you interested in tech in the first place, and maybe try to give us a bit of your developer story?
Sure, I'd love to. Like many of us, it's curiosity. So, and this is the beauty of the web, right? So there's not much that you need in terms of resources to start playing. And for me, it was the same. Build a little web page, show what you can, read a lot of documentation. Again, a very nice thing about our community. There's lots and lots of documentation, a lot of tooling available as open source. And it has always been a pleasure to explore what people have built. And this is also why I love giving back and creating open source tools myself and kind of sharing the knowledge I have acquired. And with time, obviously, you see that what you produce is valuable. And then I decided to choose a career in this area. Started with freelancing, so I didn't go the corporate route right away. Then found myself seeing that, I mean, you can do a lot of things when you develop in a certain scope, but then you see you might influence a few more things when you go into other areas of a tech organization. You might want to look more into architecture. You might want to look more into product development. I have been working in areas of organizational transformation as well. So I've always been someone who's interested in the entire area, cross-functionally speaking, of how to create value with IT. And so this is why I'm very happy to be at AWS today, where if you hear the role description of a solutions architect, it sounds very techy, and it is, obviously, right? We're talking about tech at a very deep level. But at the same time, we are talking with customers about strategy as well. We talk about them, about what they do in a product sense. And so if you decide where to go in tech, look at opportunities. Don't narrow your scope to coding yourself, although that's a super fun activity. But always think about, in the end, we are building solutions for human beings. And looking at what you can deliver, look at how you can bring the best to making good things for people.
Thank you so much for sharing this. And yeah, it's always also good to be like flexible in your role and just, time will tell what you want to do.
Yeah.
So we got two more questions. First, sometimes we are building micro frontends that could be part of a larger micro frontend, or one micro frontend could be shared between two others. Can micro frontends be nested?
So nesting at runtime is not a good idea, especially in this client-side approach. Why is that? You will realize that when you share micro frontends between teams, that you start building dependencies on them. And this will inhibit your ability to deliver. What you can do instead, or let me go one step back. So this ability to deliver is not necessarily impeded when you are aligned with the other kind of microfront development. If it lives in a different team, you cannot influence what they're doing. And then you have a dependency on a autonomous scope, and you're creating a chain of dependencies there, which will grow more complex with time. And what you will do then is start negotiating different API levels, which is also a problem because then teams need to maintain different versions of their microfront, and this is very hard to share at runtime because that obviously there is an operational responsibility. When we talk about pure client-side artifacts, this may be bearable because it runs statically on a CDN. But if we talk about a BFF or backend for frontend, that would usually be some sort of compute, like a virtual machine instance or things like that. So you want to avoid sharing runtime services that have a front implication. What you can do is extract the capabilities that you want to share into a library, right? So although it's frameworkless, you can use tooling to build your application, to manage dependencies. You will have dependencies, for instance, for multilinguality, things like that. So extract them into an NPM package, use that in your build process, and deliver a ready-baked micro frontend into your application. You might then wonder, if I share those things as dependencies and they are replicated across multiple micro frontends, will I not have code redundancy? Yes, you will. Ideally, you will not take libraries that are hundreds of kilobytes or megabytes in size, but you will use very lightweight solutions, and then the redundancy will be acceptable, in my opinion. Again, this is an architectural trade-off in the scope of a migration modernization project. So if you make a conscious choice for sharing code through libraries, then you will add a few K to your overall load, and this should be acceptable.
All right. Thank you. So, and the last question is actually too long to paste it into our banner. So let me just read it to you. It looks like all dependencies are baked into the code of a single micro frontend. As soon as I have two micro frontends who need the same dependencies, I see two problems. First, I will load code twice, which seems redundant. Second, there may be naming conflicts. How do I address these issues?
Yes, so I think I already answered the one about redundancy. Again, this is in a trade-off situation, maybe acceptable, and you obviously will try to avoid it or have the least footprint possible. The naming conflicts, that's harder because it really depends on how the naming conflict arises. What you might have is a library that pollutes the global namespace, which is quite common if they don't use proper encapsulation. What you can do is try to address this with your build tooling. If you're able to kind of transpile it to something that encapsulates this or rewrites this, you might need to fork this. In the context of micro frontends and custom elements, what you will see is you cannot simply define a second custom element with the same name in the same browser context, because this will collide. There's no namespacing at this level. So what you can do is, if you need to share custom elements as NPM packages, you can prefix them. So instead of registering the literal name of the custom element right away, you can expose the interface for registering that to the integrating component, and let it prefix the custom element, and then have this kind of namespacing conflict avoided.
Mm-hmm. Right. Thank you for shedding also some light on this. And maybe since we talked earlier about your journey in tech, and now you're at AWS, maybe you want to share with us, what is a senior solutions architect doing the whole day at AWS, or in general, like a typical working day if something like this exists?
That's a good question. So on some days we give presentations and have talks with the community, which is something we like to do. A lot of that, of course, is of the job is technical conversations, helping our customers to well understand what AWS has in solutions, because many of you may know that AWS has a very broad and deep set of capabilities, and picking the right solution may be challenging if you don't have much experience. And when you look at what benefits of going to the cloud are, it is a lot about leveraging those things to the business benefit of an organization. So this is basically our mission: help create customers value with the things we have there. So you have a set of customers, you have specializations in some areas. So I am one that has experience with web architecture, but I'm also working very strategically with my customers, along, as I said, with leadership and product management, to have a broader picture of what it means to create a digital product. But other solutions architects have other profiles and can bring other sets of value to their customers. And that's the beauty. We have internally, we form a community, and we can support each other in building value for our customer base. Together, of course, with other roles that we have in organization that all are helping to bring the cloud to people.
Bring the cloud to people. Awesome. And so, Alexander, maybe as a closing question, for all this that we talked about today, do you have maybe some additional resources to share? Could be anything, like from blogs to, don't know, YouTube channels, something like that, where people can get more knowledge about all of this.
Yes. So I shared a few links in the presentation. I'm happy to share the slides with you afterwards so you can have a look at this.
Yeah.
There is a very good book on micro frontends, not necessarily on interface contracts, but on different architectural patterns you can use when building micro frontends by Luca Mezzalera, a colleague of mine. And if you want to dive very deep into micro frontends and different ways of building micro frontend architectures, I would strongly recommend to have a look at this book and some of the blogs that Luca has written. Of course, we have a broader community. So you have seen Florian earlier today, and we have other good people that are really pushing the possibilities of what you do with micro frontends, but also related technologies that you can use to build micro frontends, like different frameworks suited for that purpose or a module federation. So I would start suggesting research in this direction, and then building that knowledge to understand what architectural decisions you will be able to make.
All right, then, Alexander, thank you for sharing so much with us today. Thank you so much also for the Q&A now. You answered lots of questions. Yeah, if you want to send us your slides, we can, of course, also add them to our recap email, which every viewer receives on Friday. So that would be an awesome addition, of course. And yeah, apart from that, thank you so much for joining us today, and hopefully we see each other on another live day.
Thank you very much for inviting me. Have a good day, everybody.
Thank you, Alexander. Bye-bye. All right, and now we are jumping to the final speaker of the day. She is technical lead at Signant Health. She enjoys building and delivering quality while also trying to have fun, which is the most important thing, of course. And she also shares knowledge by writing articles or speaking at events such as ours today. Very welcome, Michaela.
Hello. Thank you for the great presentation. Happy to be here.
Yeah, happy that you joined us today. Yeah, great presentations come from great bios. So yeah. Michaela, before we jump into your talk, would you mind sharing one or two words with the audience and me about your topic?
So basically, today we are going to look a bit onto the things that sometimes we tend to overlook because we try to satisfy our customers and we try to speed up our processes. So we are going to slow down a bit, look a bit on what can go wrong and how we can prepare for situations like this, and what are the early steps that we can take in order to create system resilience in the end.
Awesome. Yeah, preparations and safety are very important, of course. And yeah, before I steal any more of your talking time, Michaela, I would say the stage is all yours.
Thank you. Thank you very much. So, of course, I had a very nice presentation, so there is not a lot to say about me anymore, other than when I'm not in the technical side of things, coding or doing something related to coding. I like to go outdoor, be offline, and go for a good hike or just have a walk in the park to refresh. This after I just think about what I can share, what I can do better in my work, and how I can help or give insights to others related to how they can grow in their career or in their personal development when it comes to technical things. So today we're discussing about system resilience, and let's do an exercise. Just imagine this scenario where your company's site, let's say it's an e-commerce site, it's experiencing a massive amount of traffic because it's Black Friday. You're selling this thing that everyone wants. So shoppers from around the world are eager to take advantage of these sales. And suddenly a critical component of your website's infrastructure is going down. This failure, of course, could lead to losing sales, to have it frustrated customers, damaging your brand reputation. All the bad things can happen at that moment. However, your software system is designed to be resilient, and the failure is quickly detected, traffic is redirected, and that component that caused problems is just bypassed without any customer noticing anything. So things are just going further, as nothing has happened. This scenario is highlighting the importance of having resilient software systems in today's digital landscape. With downtime leading to such significant financial losses as we are discussing, and damaging the customer trust, the ability to withstand all sorts of failures, network outages, cyber attacks, traffic spikes is in this case. Having system resilience is not just some fancy thing that we might have, or an advantage for the competition, but more like a necessity. We need to look into this. And resilient systems ensure that a service is continuing to work. It's taking care of data integrity, maintains the user satisfaction, as we just mentioned, and no matter what challenges we are facing, helps us being prepared and having a fallback for that, or at least some sort of strategy to work with. In this presentation, we will explore the fundamental principles and strategies that make such resilience possible, from redundancy and failover mechanisms to discussing a bit about some options like that bring advantages in this area, such as using right a microservices architect, or load balancing, and beyond. So we will take them one by one a bit later in the presentation. But for now, when it comes to ensuring system resilience, it's important to understand faults, failures, and the mechanisms designed to mitigate these issues. And to do so, let's take our example from before and go back a bit to the Black Friday season and think, okay, how can we find this fault issue, or how we can identify it? So in a crowded environment like this, as we are discussing, a lot of things happening, a lot of customers and actions and so on, a fault might be hiding in the system. It might be a piece of code that does not correctly handle a specific kind of, the usual user input. And this fault can go unnoticed during the regular testing because it's only becoming available. It's only creating problems under specific and very rare conditions and configuration even. So we have this fault in our system, but as long as we don't touch that specific case, everything goes very well. So we don't know about it. But let's say as the day progresses, this rare condition finally occurs, and the user just types some input, and that input triggers the problematic issue, and is causing the service within the website to crash. This is when the fault escalates into a failure. Suddenly, customers start to experience errors when trying to add items to their shopping cart, which, yeah, it's a very important problem in an e-commerce experience and platform. So to keep the website on, we need to ensure that we have fault tolerance. And now let's be clear, problems will appear. There is no perfect, always incredibly well-working platform. But this does not seem that we have to be just like, okay, this is it, this happens, we'll just deal with it later. No, we need to go ahead and see what we can do about it so that we can ensure that our website is available for user. And if something does happen at some point, we have a way to recover smoothly and rapidly. So let me explain. Fault tolerance and fail-safe systems play a crucial role in disaster recovery because they reduce the chances of a complete disaster and limit the damage in case of failures. Fault tolerance allows systems to keep running through any issues, minimizing their impact and reducing the need for disaster recovery actions. On the other side, the fail-safe mechanism ensures that when systems fail, they do in such a way that, they either make the recovery quicker and the user almost doesn't notice that something has happened. So together they create a resilient foundation that makes disaster recovery more manageable. And it's ensuring actually faster restart of operations with minimal data loss and minimal downtime and minimal bad user experience. And the same goes for availability. We improve systems availability by ensuring that everything continues to operate during this kind of situation. So when combined, ensuring the availability and taking care that we have disaster recovery plans, we keep our services accessible to users with minimal interaction. So then we can say, okay, we have a resilient system. We can at least say we know where to look in order to cover this important part. We were discussing about downtime and why is it this important? It might not be seem like a big problem when, for a little bit your service failed for some seconds today. But when we're putting it together in a year or more, looking at the big picture, we are going to see that this is actually impacting the business long term. And also the user experience is, even though it might seem that it's not something that is triggering, it becomes triggering at some point, even though it's just a small amount of time from time to time. Okay, so let's see what's to do. How we can work around this reality that we have, because we are just discussing that this happens. So clearly, modern software development faces a lot of challenges because of this, rapid technological advancements that we have, and we have maybe or complexity in the systems, and then also the attacks that systems can suffer are evolving too. And on the other side, we have the users that have some greater expectations than they had, let's say, 5 years ago. So to meet the demands of the digital era, we in the team need to focus on continuous innovation, efficient management, and in the end, to deliver high quality software. And the continuous evolution of these technologies and the programming languages can make it hard sometimes for teams to stay up to date and choose the most, the best solutions for their project. Because we are discussing about this complexity that is appearing. We think that something is going to resolve a problem that we have, and we are using this last pattern that we heard of that is so great, but then we realize that we are integrating multiple components and services and data sources, and we lost track of what is happening in there because actually that pattern was not suitable for our application. So all of this make our systems more error prone and harder to maintain. We discussed about user expectations in terms of, from user experience to performance. So this is something that we also need to take into consideration. And beside working on this application infrastructure part, we also have to take care of, solutions that are user-centric. So we need to take a lot into consideration when we are discussing about all this landscape that we are working with every day. So despite advances in this area of resilient software design, some challenges remain in there. And I'm not sure exactly if it's that because people are just not able, we are specialists or as developers or as people that are making decisions about this kind of important topics, we are not maybe aware of the bad decisions that we are making, or if the tools that we are using are being used in a bad way. I think this differs from product to product. But let's say that, for example, as a system grows and becomes distributed, managing state consistently, across services becomes difficult too. So we might think that, okay, I'm going to use, let's say, microservices. Yeah. Well, okay, but we also have to think of the complexity, or how that is going to go in the context of the product that we are trying to build. Yeah, we are not just going to look at the bright side and be like, okay, this is the best, and I heard such good feedback from it, and I don't have to look into the details because I know for sure the feedback is so good, but I know for sure that it's going to work for my context. No, we need to look a bit into the details, understand what we want to build, understand what we are going to use, and what is going to actually bring value into our project, and strike that balance between over-engineering for resilience and avoiding some anti-patterns. I think that this, in the end, is it's something that is going to, I dare to say, lead for a good success. Systems where components are closely linked can be fragile. And then again, we are going back to, okay, but if I'm using a distributed system, I may get problems with managing state. So we have to look exactly of what problems we are trying to solve. Like, look exactly into the context of our product, see the problems that we are trying to solve, and then see how all of these are going to work together in the end, in order to avoid having like a domino effect where failures are happening everywhere and we don't know exactly what is the problem or where did it start. Achieving resilience in software systems requires an extensive approach where different layers of the software stack work together to ensure overall robustness. There is no magic trick like, as I was saying, I'm finding this solution and I'm just going to go with it because I know it's the best and I don't have to worry. I'll see you in 10 years or something. No. We have to look at all layers: infrastructure, application, database. Let's just go through this for a while. So at the infrastructure level, we need to have some backup service, failover mechanisms, some geographic distribution in order to spread resources across various regions to mitigate, some localized issues if they might appear. This helps a lot in achieving infrastructure resilience. Then we are discussing the application layer. And in this area, we can think of effective error handling, ensuring graceful degradation. For example, I want my system to continue to function even if it's at a reduced capacity when a failure is happening. So I don't want it to disappear for the user to not be able to do anything anymore. And of course, we go back again to strong state management. Then we have the databases, critical components for many systems. And we need to ensure that we have strategies that involve replication, that involve regular backups, that we have the data distributed across multiple databases. So we are not putting all the information in one place and hope for the magic tool that we started using, I don't know, 2 years ago to do the trick and take care of everything. And last but not least, I think going beyond the technical part, we need to discuss about what is the impact of people in these problems. And I'm talking here about team dynamics, quality and continuous improvement culture, collaboration, continuous growth mindset. These are an extremely important, or create an extremely important pillar of resilient systems. I've seen amazing strategies and architectures fail because they were not understood and implemented by everyone in the team and at all levels. So we had such bad communication and such bad sync that this amazing architecture that was, of course, complex because of the nature of the product, and still it did not help until we did not actually have a team of people that was working and looking into the same direction and understood exactly what it is to be done. Then, going a bit further, one of the most important aspects is implementing redundancy and failover mechanisms. So redundancy means having multiple copies or backups of the same data or resource. This ensures that if one fails, another one can take over. So failover involves switching to a redundant or, redundant system in case of a failure, or if something happens that we did not thought of in the beginning. So it's like a safety net. And these mechanisms can help prevent data loss and the downtime that we are discussing that is so important, and ensure the availability of our product in the end. Then we have load balancing as an approach to ensure that our systems are not going down completely. And load balancing enhances system resilience by evenly distributing incoming traffic across, let's say, multiple servers, and prevents, for one specific server to become overwhelmed and to have maybe the most important traffic in there, and then when it is failing, everything is failing. So this ensures smoother and more reliable services, reduces the risk of server failures because of this distribution, or thanks to this distribution, and allows updates without disrupting the user experience in the end, which is also something that we need to take into consideration. I think that it's safe to mention in here also another way to work towards resilience, which is to distribution of load. We can use availability zones that improve system resilience by physically separating data centers within a region. So this protects against failures and allows for rerouting of traffic to available zone in the event of, if one of them becomes unavailable. Another approach that I've been mentioning in the beginning, that I was saying that it can go either good or it can also go bad, is the microservices architecture. Basically, it boosts the resilience and robustness of a system primarily through some of the benefits that this approach has, which is decoupling, scalability or independent scalability, and fault isolation. Of course, keep in mind that there is no silver bullet you can, take and create a perfectly good product. We need to understand the context that we are working with and avoid a big fail just because of some fake trust that we have, based on information that we've been gathering without actually checking how they are working in our context, like creating a proof of concept and seeing exactly how things are evolving in time. So understand your context before choosing any of these approaches, and understand how to implement them correctly before actually starting and going, with a big load and making important decisions. Some additional techniques that can help to improve the resilience of software systems. Let's say we are essentially taking an approach to ensure that our systems can withstand. So we have this base part, that we are taking care of, but maybe there are some other things that can help us ensure that our systems can recover and maintain their operations in the event of unexpected incidents. And sometimes, as we are going to discuss further, maybe we think, okay, we are discussing about microservices and load balancing and availability zones and so on. Sometimes maybe we think, okay, but if I'm just someone in the team, I'm a developer in the team, right? I don't have the power to go towards that. I don't have the power to impact that. So maybe that is not my job. And then I'm going again to that idea that if we are not working as a team, and if we don't have the same objectives, and we think that, okay, this is not my job, I'm just going to do my coding the way I've been doing it until now, we are going to find failures at some point. Sooner or later, something is going to bring some downtime. So as we touched already the subject of disaster recovery, I just want to say that an important process that helps organizations prepare and respond to unexpected events, such as cyber attacks, hardware malfunctions, I don't know, natural disasters in the end, because this is something that we cannot work against. We can just prepare for them. Might be creating a risk assessment, identify potential risks and understand the potential impact of these risks in order to prepare as we should. And we really need to think of like the most improbable things that might happen. Then doing some critical asset identification. Organizations can identify the systems and data that are most essential to their operations and prioritize recovery efforts to ensure that these areas, these critical assets, are brought back online quickly in the event of a disaster. So we need at some point to also make some important decisions of this kind. Recovery strategies, we already touched that, but once critical assets have been identified and risks are clear for everyone, organizations can create specific strategy to recover these assets. Communication plan, again, it's essential to ensure that everyone involved in the recovery process knows what is happening, what they should do, how long this is taking, how things are progressing. In this way, we reduce the stress and confusion, especially in high pressure situations like this. And of course, regular testing and updates in order to see that all the changes that we did, all the updates that we did remain effective and that they are not causing any other issues in another area. Then the security part, we were discussing before about how can I as a developer impact such an event, how much impact can I have as a developer? Where let's just think about securing code. When I'm securing code, it's similar to building a fortress in software. It is about having the guidance in the development team to write code that is not only functional and that works and everything is okay, but also to be prepared for attacks. This involves protecting against the common vulnerabilities like SQL injection and cross-site scripting, but it goes also to understanding principles such as the least privilege and ensuring secure sessions and having the training and the information about what else might appear as we go through the process of building a product. And one of the approaches, let's say the supporting strategies, goes in the part of monitoring and alerting. I think that we don't understand exactly how important these are until the point when we actually have a very serious situation where we need where some feedback it would have been needed and useful, and we did not have that. So monitoring tools act as our eyes and ears, and they are continuously scanning our systems to gather and present data. They assist us in defining normal system operations so we can prompt, identify, and work on any out of the normal scope that might appear. By understanding and implementing these strategies, this kind of approaches, we enhance resiliency, of course, and we ensure that our systems not only withstand disruption, but also recover and actually thrive in the face of these challenges that might appear, that as mentioned, they are more and more complex and harder to identify as the whole scene of basically technical domain evolves, if we can think of it like that. It's so wide and so complex that it's even hard to define. Then, okay, if it is to step for a second, we've been discussing about the strategies, so we know what we can do in order to prevent situations like this. But let's see how we can. Is this something that we are doing just in the beginning when we are starting to work on a product and we are creating the strategy, and then we're just leaving it like it and hoping for the best because we use the strategies and we used the all the best practices, so we should be fine? Or is something that we can do in a cycle in order for us to see how our system is evolving and adapting to the environment that we are using? And in here I see two steps that we need to go in cycles through them on and on. One is the continuous testing, which is similar to having a health checkup at regular intervals, rather than waiting for your symptoms to appear. And by identifying potential problems early on, continuous testing reduces the risk of failures in production environments. So this is something to take into consideration. And automated testing is the backbone of continuous testing because it involves setting up some tests that run automatically whenever changes are made to the code base. And this could be unit tests that check some small pieces of code, could be integration tests, could be security tests, load tests, and so on. So sky is the limit in here. The key is that these tests are automated, so we don't have the human error involved in it. And also, since we don't have someone that has to do this over and over again, we speed up the development process and we make sure that software quality is enhanced. Then learning from the future, from the failures. Well, we might think at failures as something that it's scary and we need to protect ourselves against. But how about we also think as some valuable learning opportunities? Because in a moment when we are receiving this kind of feedback, we actually are able to understand much more about our system and how is it evolving, and what are the approaches and the strategies that we can use in order to improve the systems. And based on this, or how we can actually work with this feedback, this means conducting some analysis to understand what went wrong, why it happened, how similar issues can be prevented in the future. And basically we come to the point where we take a failure and we just we strip it down by all these details, and we transform it into another important lesson and action that we can take in our system in order to improve it for the future and prepare it for the future. And in this area, sky is the limit. We have a lot of options that can help us in adding even more and more resiliency into our products, from designing the resilient architecture, of course, to implementing some static analysis practices, or we can use continuous integration and delivery practices, in order to create a lot of, to work with automating the build, the test, deployment, everything, in order to ensure that we detect as early as possible this possible defects. Then we can discuss about monitoring and alerting, as we are discussing the culture of collaboration. So the spectrum of working in this area is so big, and is giving us a lot of options that we can work on and integrate in our systems. Now, this slide is for the ones that don't know where to start. Maybe they are at the beginning of their career, maybe they are freaking out to everything that we just discussed, or maybe that you heard in this area. So let's think of this as a first step. As a software development team, if you want to make sure your system is resilient and you don't have the impact maybe, or you're working in a organization where you don't have a lot of, you're not higher in the decision-making process in order to actually make what we consider a big impact, still you can create an amazing impact by starting with the core quality attributes of your software, like its performance, security, scalability, maintainability, and availability. By providing these areas, you can build and have more impact that you can imagine. Treat each attribute as something that, if you straighten one, indirectly boosts your system's ability to withstand with shocks. So measure your progress all the time, set some goals for yourself in the team, work on improvements one step at a time. This time, you're not, just taking blunt shots, but making informed decisions, and the changes that you're making are really impactful and enhance the entire system's resilience. By focusing basically on these fundamental quality attributes, you can create a strong foundation for system resilience without being, involved in the early decision-making process and discussions, because this is not something that we are doing just at the beginning of our product, when we are starting working on it. Well, if you look to the future, of course, we can imagine a world where systems are designed to adapt and to recover, and advancements in artificial intelligence and machine learning will enable systems maybe to predict and prevent failures, while real-time data analytics will help to refine our understanding of system behavior and how they work under stress. And as software professionals, it's important that we embrace these innovations and make them a part of our practice. We need to foster a culture of resilience thinking, and when we are building systems, we are thinking about how they can withstand and adapt to the unexpected, to wherever today is something that we are so amazed by, and we don't know what it appeared from, but tomorrow is just going to be the norm, and we need to find the way to create a mindset of always adapting and always working with the latest flows, also not only with the latest advancements. So maybe the most important lesson that we can, or conclusion that we can draw from our discussion on building systems, is the need for a proactive approach. From my experience, and actually this is one of the lessons that I've learned, that by anticipating challenges, engaging in continuous testing, automated processes, and learning from every setback, we cannot only react to problems. It's exactly, always staying in this stressful vibe, but more like prevent all these problems that might appear. So together we can build systems that are not only working against today's challenges, but they adapt to tomorrow's new things and uncertain situations that might appear. So thank you for being part of this essential dialogue, and I'm more than willing to learn from you too. So let's see, what are the questions? Thank you.
Thank you, Michaela, for the awesome talk. And yeah, we got some questions from the audience. So I would say, let's tackle them right away. First one, how do you ensure that security practices don't compromise system performance or resilience?
I think that this is something that we have to look very closely. In every system, when we are, but not only in the beginning when we are building the system, but in every system we have some things that we know that are the most important. For example, for some systems, performance is very important, but there is no need for a high level of security in that area, because let's say no impactful processes or damage can be done to the data. It's not something that we can stand with the basics, let's say. Then we have systems like, for example, when we are working with people's data or money, we need to be very careful about how we are dealing with security practices and how we are working with all of our power to secure, basically, in the end, this data, and make sure that we have the trust of our customers. From my opinion, when we are working towards creating a resilient system, it doesn't have to be a trade-off, because as I was saying, resiliency, it's not like we are trading security with or performance with resiliency, but more like we are taking them all, taking this together. We are creating the context, looking exactly what we want to build, and see how exactly we can match the pieces in the puzzle. So yeah, I think that it depends from context to context. This is like a consultant's answer, right? But with the lack of details, I think that it doesn't really have to be a trade-off in the end. I think we just have to see exactly what are the objectives that we have, and also how we can integrate what we are already having or what we are building in order to not compromise.
I was just smiling because I already joked today with the first speaker about this "it depends" answer, because
yeah
it is so. Yeah, it's many speakers give us this answer, and yeah, you're totally right.
Yeah, because
in many
there
cases,
are so many
depends.
scenarios. Yeah, there are so many scenarios, and that's why I think I kept repeating myself in the presentation about the fact that it's always important that we look at the context of our product and to see exactly what we have, what we are working with, and not make decisions just because someone at the presentation says that we should do things in a certain way, but more like considering that option and seeing if it really works.
That is so true. Thank you for that. And we move on to the next question. How do you prioritize which components of the system to focus on when designing for resilience?
I'm in here. I'm thinking when we are saying, when we are discussing about components, I'm going to assume that we are discussing about what are the most impactful ones. As we are saying, you can, let me think how to put my my idea in order. So if I'm doing in I don't know, in the application, I'm in the application level, let's say. If I'm working with you know, maybe I'm not really paying attention to, I'm not aware of resiliency or things like this, so I'm just working with what I know. I'm just doing some development, and I'm doing something bad in there that might be impactful. It's still going to fail later, and it's going to fail in a way that if I don't have a strong infrastructure, it's going to go down. So a very small thing is going to create a major problem. But if I'm doing this very small thing and I have a strong infrastructure and I have strong strategies in that part, either I'm, as I was saying, I have the possibility to switch from one server to another, or I have the possibility to decrease the load on maybe the server that I'm affecting with that small coding part that I did. It's still, if I have this in place, it's still going to save the situation. If not, it's going to fail big. So I think that the most important part to take care of is to see exactly how we are distributing the load, how we are working with how our application is going to evolve in time in terms of data and in terms of the load of users, and be prepared for that. Because if we are preparing in that direction, most probably are going to use the approaches that we've been discussing today. So from my perspective, it goes, you know, from the, let's put it like this. There is this concept of sharing layers that is being taken from, you know, building architecture, that says that some layers are easier to change and some layers are harder to change. So when we are discussing about the infrastructure, the architecture, and so on, these are things that is going to be later harder to change. So we really need to, like, they are impactful. If we do something wrong in that area, is going to create some risk for us. But if, as we go up and up to, you know, from the architecture, we are going to how I'm going to design the interior of my house, those are things that I can work with, like nothing of high impact in there. Of course, I might not have the best Zen vibe, but still is not something that I can change later. So maybe the good approach is to always think in terms of these sharing layers. Think about the things that are harder to change later, to you know, put something else in the place of that, and prioritize by thinking about this.
Mm-hmm. Yeah, so the more dependencies a component has, the harder it is to change afterwards, of course. So, and Michaela, thank you for that answer. We have one more question from the audience. Do you have some tips on how to effectively communicate the importance of system resilience to decision makers within an organization?
I think that most of the time when we are discussing about you know, higher level of in decision making, we have to present very clearly what are the financial losses that we will have. Because if our product is not available to our users, if they can't work with it, and they slowly are, you know, not using it and leaving to the competition, this is something to take into consideration. So sometimes it might seem that new features will bring more value, and in fact, the real value is in our hands to do some technical magic behind the scenes in order to improve that. So yeah, but also is not something that you can just go, you know, discuss with someone from management on the hallway and be like, okay, this is an issue that we have. I think it's something that you need to document with very specific data to create a case for this. Always, if you want to make a change in your product, be prepared and create a case about that and present the benefits and the advantages and the financials and so on. Go with numbers.
Yeah. Okay. Come with examples. Yeah, of course.
Yeah.
All right. Thank you for that answer as well. Michaela, you're a tech lead at your company. And do you mind sharing maybe a bit with us how you became interested in tech in the first place, and how did you get to this position where you are now? Like your developer journey, if you might say.
Sure. Even though I started, I've been in the tech field, let's say, since I was in high school, because it was a technical high school, let's say. I can say that I was very excited about it from the beginning. I was just doing the task that I had to do in order to finish what I have to do. So it was really very, like a little robot. But then somewhere on the way, I started working. So I was just doing it because, it's interesting and it's nice and I like math and so on. But somewhere in the process, I stopped into a team where I understood exactly how quality products are being built and also how quality relationships in the teams are being created. So how much they were crafting the product that they were working with, and the attention to the patterns that they are using, and even the name of a database table. It was something important to take into consideration because it had an impact later. So by having the being in touch with this kind of mindset and culture and such professionals, I started liking it. So it did not seem just like, oh, I'm writing code and whatever, I'm just doing my task at hand, but more like I started understanding how products work, and I started being interested and then frustrated because I did not understood all of the things that they were using. So this awakened in me this eagerness of learning and becoming a good professional. So I think that from then on, it just went in cycles, like finding about something new and learning about it and giving it to others, giving the information to others, and then seeing that there is something else that I don't understand, that I don't know, that I might find useful. So it goes on and on and on. So that's how I started my interest in this field. And then from then on, opportunities just appeared, and I was just looking for teams that help me grow and that have or that I can also help grow in the end.
Awesome. Yeah, it also shows that when something becomes a passion, then the process becomes very organic. Like your shift from like this, you said it was robotic at first.
Yeah.
And then it became like, just this journey. Awesome. Michaela, thank you so much for sharing all these insights today with us. It was a pleasure having you. Thank you for the talk. Thank you for the Q&A. And hopefully we see each other again on another live day.
Thank you. Thank you for having me. And you can find me on LinkedIn, on Twitter. Let's discuss. If there are any other questions, ping me in there and let's talk. Thank you very much.
Thank you so much. Bye-bye.
Bye-bye.
All right. And now that also this live day comes to an end, scroll down on our live page. We have our partners listed there. Their logos are clickable. Check all of them out. Also, don't forget to check out worldcongress.dev, where you get further information on our upcoming in-person event, again in July 17th to 19th in Berlin. Make sure to be there and make sure to grab your ticket. And I hope we all see each other again at the Web3 Day, which is on April 3rd in 2 weeks. So until then, bye.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to 130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.